Hello, hello, Shagathanoon here. Welcome back to another Rust coding stream. We are once again doing the roguelike tutorial in Rust with tcod or libtcod. And we're going to be picking up where we left off last time. So yeah, here we are today on the 19th of September 2022, local time 1740. Running a little late, but it's okay. Last time, this is what we have. We left off with the basic map generation, character movement, and like a field of view, basically, that so we can get a little bit of an exploration feel going on here in the map. So, oops, I'm trying to use traditional roguelike keys with the numpad. Can't do that. I've been playing a lot of Cataclysm Dark Days Ahead, where you would use those keys, or you can, you don't have to, I guess, but here we are. So we can explore the map a little bit, just kind of showing what we left off with last time. Pretty cool stuff. Hello there, Tusk. We'll explore this map one time, give it a good go real quick, and then we'll get started with the next section of the tutorial, and this is going to be a fun one. I'm excited for where it's about to go. So, almost done with the map here. I can't remember what the max number of rooms are, but it's not all that many. And we've got it drawing these horizontal and vertical connections between the rooms as they spawn, so we know all rooms will be connected in one way or another. Looks like this room over here is orphaned off all by itself, and now I'm happy because we've uncovered the whole map. Okay, so let's go ahead and back out of this, and let's get back into the tutorial, and like I said, pick up where we left off. So if we go back here to the browser, if we look over the chapters here, last time we did graphics, we did the object and the map, we did the dungeon, and we did field of view and exploration. So what I want to do is try to do 5 through 8 or 5 through 9, depending on how long it takes. And then the time after that, we'll do whatever's remaining. So all the way through part 13 on Wednesday. So that's the objective. So part 5, preparing for combat. Let's go ahead and jump right into it. Okay, so we have an explorable dungeon now. Yeah, but when you actually go through it, it feels a bit boring. It's just empty rooms connected to more empty rooms. Let's add some monsters. This isn't going to be as bad thanks to our object system. We create an object for each monster and add it to the objects list. So all we need to do is create a few monsters in random locations for each room. Let's add a function that takes a room and does exactly that. Okay, so we're going to make this place objects function. Let me not knock my drink over. I've simultaneously wanted to take a drink, but also switch the scene, and then I almost knocked the drink over. It's like a little bit too close. All right, so we're going to add this place objects function. So, assuming I did this right, let me double check and make sure you're looking at the code. Good. All right, place objects. And I still need to get used to talking about not what I'm typing, so I'm gonna, maybe ramble a little bit as I go through this. But yeah, as I mentioned, I was been playing a lot of Cataclysm Dark Days Ahead, which is a pretty traditional roguelike. Well, traditional in the sense of very hardcore. It's ASCII based, but you have tile sets that come with the game, and you can add more. So sometimes, like, I was just literally trying to control this game like I was playing that game, because I've been playing it a lot. I've been having a good time. I played it a bunch last night off stream on a new map that I made just so I could keep playing it when I wasn't streaming. Oops, okay. So here we are. So we're going to be declaring this number of monsters, and we're using a constant that we haven't declared yet. I'm just looking ahead to see what they call that constant, or what they define that constant as. So const max room monsters, it knows I32 equals 3. So there can only be 3 monsters in a room. Getting smacked by a Hulk zombie. No, not last night. Okay, so we're just gonna loop through. We don't actually care what the number is, but yeah, we generate this value of some number of monsters, and it's basically there could be 0 up to however many monsters that that constant defines. And then we're going to choose a random spot for this monster. So it's going to be 2 of these thread RNGs, basically. Romo. No, not that. Room. Okay. We're going to copy this again. And we'll change this to Y. It should be Y1 and Y2. So this makes sure that the values we get fall within the walls of the room. That's why we do a +1 on the low value and we don't do a +1 on the high value. Let mute monster equal if random f32 less than 0.8. So this gives us an 80% chance. Whoa. Go back down where you belong. This gives us an 80% chance of getting an orc. So we'll say create an orc. Object, new, X, Y. And orcs are represented by an O. Colors, desaturated green. I missed a letter there, but we'll just autocomplete to fix it. You are right, Tusk. I forgot about that. I did see Shoggoths yesterday, but they weren't real. Okay, yeah, something's weird. Less than 0.8. Put this up here for 1. Oh, it's random. Oh, it auto-completed this in here earlier. And then, yeah, that's what's throwing me off. Okay, that's better. So else, we only have 2 options right now. Object, new, X, Y, T, capital T. Colors, dark, green. So this is a troll. 20% chance of a troll. Oh, and actually, we're doing a bit of a more complex conditional here, so we're going to get rid of these semicolons. Where is my cursor there? Get rid of those semicolons. And then objects, push, monster. So what we've done here is we're treating this conditional, this if-else, as a statement. So the if here returns, if you will, this orc, this O, and this else block returns the T for the troll. We've assigned it to this monster variable. And then we're pushing it in here. Now, I'm not entirely sure why it's mutable. We'll see if there's a reason for that later, but it is complaining that it's mutable and it doesn't need to be, because of course we're assigning it once here, and then we're just immediately pushing it into this objects vector. So I'm a little bit curious. We'll see, right? So let's go ahead and get back to the thing over here. Okay, so we define max room monsters. Calling random F32 will produce an F32 between 0 and 1. So 80% of that is 0.8, which makes sense. As you can see, we're defining orcs and trolls here, but you can do anything you want. And as we add more properties to object, you can set them all here and create any monster or NPC item your heart desires. Later on, we'll use a choice table to make the code cleaner, but for now, you can just extend the if random else block to add more variety. To actually place the monsters in each room, we will call this function right after create room in Makemap. Okay, so we got to go back to Makemap. So we're going to do that, and we're going to update the signature of Makemap to take an immutable reference to our list of objects. We'll also stop returning the starting position. Can be accessed. Okay. So we're changing Makemap to just return map. I'll have to take a look at what our current signature is as we do this. And let's set the player's position when we generate the first room. So there's going to be a few things happening here. We're going to set the player's position. When we call Makemap, we pass an immutable reference to the entire objects list. Let's also remove the dummy NPC from the initial objects list. We don't need it anymore. So there's a bunch of things here I just read over. We're going to go ahead and do all those. Because anytime I see a bunch of short, quick things like that, I want to try to cram them in once so I'm not flipping contexts back and forth too much. Okay, so the first thing we want to do is make map. So fn make map. And right after create room, we'll place monsters in there. Place objects. And it's new room and objects. And we need to actually add that into Makemap. So right now we're just taking the player, but what we're actually, what we're actually doing here is we're gonna say objects and mute vec object. So that satisfies everything but the player. So what we now need to do is in here, we will say objects player. And that's something we haven't yet defined. I don't see them defining it here in the code I just ran through. So we'll see where it happens. Okay, yeah, they do it in a moment. Okay, good. So it's basically a constant though, because we know where the player is going to be located. So we've got that in place. Now we're accessing the player from here rather than hard code passing the player itself. We know where the player is going to be at. We'll see how it works in a moment. When we call Makemap, so Makemap, we need to pass in all the objects. So that right there. And it expects a vector. I was curious about that because we were passing an array before. So yeah, we're changing how we're defining it here. So instead of this player and NPC, it's now vec like that. And we'll just go ahead and get rid of the NPC that we had before. And that should satisfy everything except for the player constant. So then I'll click back over because they describe a little bit about how this works. So let's get a handle on that. So getting hold of the player's position. Before we move further, there are two things we can do to make working with the player object easier and also to get and set the position of an object. We've already typed object 0 a few times to refer to the player. To make it a bit clearer, we'll define a new constant player with the value 0. Put this among the other constants. And now we can replace every usage of objects 0 with objects player. We have one in the main function, one more in render all. It's a bit longer to type, but the intent is much clearer. Now add these two methods to object. And these give us a shorthand for getting or setting both coordinates x and y for an object at once. This will again simplify some code in the main, the move by method of object, as well as setting the player's initial position in Makemap. Okay, so we're gonna run through all this real quick. The constant and stuff for player, really easy. Literally const player, and what is it, an I32 or usize? Oh yeah, it's usize because we're indexing with it, of course. Okay, so usize, and then basically I'm gonna do this. They listed out where it's being done, but I'm gonna be a little bit lazier and just do Control F right there for objects 0, and we're gonna say objects player. And I'm just going to bulk replace those. There should only be a few of those, but that should get all the way. I feel like that captured a couple that they weren't even calling out, which is interesting. It says we have one in main and one in render all, but I just found 4. It's okay. The code's happy. It's compiling now. I would run it, but let's wait a little bit longer and get a couple of these things refactored. So we want to add a couple methods to the impl block for object. And those are going to be pub fn position or POS. And it's going to return a tuple of I32 values. And it's really easy because it's just self.x and self.y. Very, very easy. And then the other one is going to be to actually set the position. So it's basically the same thing, just in reverse, as in we're going to take in a mutable reference to self, and we're going to take in an x and a y. And we don't need to return anything. So we're just going to do self.x equal x, self.y. I know I can't, I need to fix that line above. We'll do that in a second. Cool. So we set both of those. Again, that's just going to be a shorthand for working with those. We're going to be able to replace some stuff, and it's going to be a little bit cleaner looking. See how it gets used. Okay, so next up, back in the browser, blocking objects. If you tried to walk up to a monster, you'd see that the player would walk right through. That's clearly not what we want to happen in general. Plus, we don't want multiple monsters standing on the same tile. But there are other options, scrolls, potions that should not block the tile they're on. So the question is, does it block? Let's update object with information whether it blocks the player or not, and give each object a name while we're at it. Put this in the object struct definition. So we're adding name, blocks, and whether or not it's alive. And then we'll change the new method to take in values for each one of those. So we have name, blocks, and I guess we're defaulting alive to false. Which is interesting. We'll see how that plays out. It says all of our objects are alive at the moment, but soon we'll add items, scrolls, stairs, etc., and the balance will shift. Better set things alive explicitly than turn it off. It's easy to see when you've missed setting alive equal true, but hard to do the opposite. That's the reasoning. Okay, so let's go ahead and get all that handled. Seems straightforward enough. Let's go back up to the object definition. And just for posterity, I'm going to do things in the same order they do. So name is a string, blocks is a bool, as well as alive is a bool. And now this is mad here because we're not accounting for all those. So in this case, they take the name in before the color, which is annoying to me because then I have to slide this in the middle of our new. But name and stir. And here we have blocks bool. Okay. And so we have object x, y, char, color. Name is name.into. And we have blocks and alive. Oh no, we're not taking it right. Alive is false. Sort that. Okay. Looks a little bit different than theirs because they're explicitly labeling each field, but you know, like I could do X, but it actually will, it should format that away. No, it's not, but we can get away with just doing it that way. Okay, so then next up, we're going to create a function that tests if a tile is blocked, whether due to a wall or an object blocking it. So I'm going to put that down here at the bottom. Like right before main or something. Place objects. Oh, yeah, you're mad now, so we're gonna have to update you in a minute too. So we're gonna make the is blocked first because we're going in order of the tutorial. Y I32 map and map objects. And if I remember right, map is actually just a type. Yeah, it's just renaming a vec tile. Okay. Now I'm curious why we have this here as an array rather than a vector. I think you could I think you can dereference or something. We'll see how that's used because that one's a little curious. We explicitly made a vector of objects and we're declaring it as a vector of objects, and now we have a an array. So we'll see how that works out. A reference to an array. So we'll see how that works out. Okay, so the first thing we want to do is test the map tile. And if map x as usize, y as usize, got blocked, turn true. Now check for any blocking objects. So what we want to do is say objects dot iter. I'm trying to get the formatting to cooperate. Dot any. Okay, so this is something that went a little bit over my head last time I did this tutorial, because I wasn't as familiar with doing this more functional kind of stuff. But I actually really like what they're doing here, using the any function. So basically, what we do is if anything returns true, it's going to go and do this any on every single thing from the iterator, and if anything in here returns true, then the whole thing returns true. It basically short circuits because you only care about one. So what we're saying is if the blocks variable on the object we're looking at right now, if it's true and it's on the same position that we're currently looking at in the map, then that object is blocking the position. That's the idea. And so I really like that. That's, if you were going to do this in more of a traditional kind of programming, like C or something, it would be, and we can't do like a C for loop, like I equals 0, I less than whatever the value is, total tiles, I plus plus. Like we can't, you know, obviously we can't do that here in Rust, but let's imagine we can. Then you would do something like, you would then do this check here. This isn't quite right because this syntax doesn't really work for C++ or for C, or well, kind of either. You could do some overloading, but I don't know if you'd really be able to cleanly do this, since the tuples don't really work the same in C++, and they're not at all in C. But the thing you would basically do, you'd build this check in here, and you would basically say, if that, then return true. And you're looking for that more explicitly, where here we get to feed it into this nice little iterator thing. To me, it's much cleaner when you start to break down how it actually works. We have to modify this a little bit, and you'd probably say dot position x equal x and object dot position dot y equal y. This is more what it would probably end up looking like in C. Now, it's not perfect. I mean, we're not building it in C, but that's the idea. That's why I really like how these iterators work here in Rust. It's very good, very like kind of close to functional, but not really. Just close enough, right? So let's go back over here now. Ownership woes. So now we'd like to use is blocked in the move by method to make sure an object never moves onto a blocked tile. If we just put the not is blocked self.x, self.y, plus dy, you know, whatever. If we put that into the method and add objects as a function parameter, Rust will not let us use it. This method will compile just fine, but if you try calling it in handle keys, the program will not compile. Rust will complain that it cannot have a mutable and an immutable borrow at once. Yeah, so that's the thing. Actually, I think we might break the rules down here, yes. So to guarantee memory safety and no data races, Rust references and mute have a few rules. One of them is that when you have a mutable borrow, you can't have any other mutable or immutable borrows into the same data. Well, without doing some trickery, basically. Like a reference count or something that allows you to basically lock the data down. And that's exactly what's happening here. The signature of the move by method is, so mutable reference to itself. We have these objects here. We need a map and object because they both need to be passed to is blocked. But we also need the mute self at the beginning to be able to modify the position of the object we're moving. Right, and therein lies the problem. Since all objects, including the one we're calling move by on, are in the object's vec, as soon as we mutably borrow one part of it, Rust locks the entire vec. The line above is essentially equivalent to this. So this is what I called out earlier, where I was like, it's kind of weird that we're taking in this here rather than an array, right? Or rather than a vec. And I think that's because we're going to be doing slicing here. We'll see what actually happens. It's been like 2.5 years since I've done this. But yeah, so the idea is let player equal, and then we're grabbing the player from the objects, and then we're basically borrowing all the objects, and then we're trying to move the player. So that's where the double reference thing comes from here. So yeah, get immutable, borrow the player. That'll treat the whole objects vec as mutably borrowed. Try to immutably borrow objects. Fails because it's already borrowed. And we don't even get here because the double borrow issue on line 4, that is. So there's multiple ways to solve this, but the easiest is to turn the method into a plain function and pass in the object index instead of a reference. Now we no longer have the problem because we first get the object's position, immutable borrow, that ends immediately, then call is blocked with objects, again, immutable borrow that ends right after the call, and finally with no borrows to burden us, we set the position. This is what Rust people sometimes refer to as fighting the borrow checker. When you start with the language, you'll likely encounter a lot of these situations. As you get more experience, though, you'll learn which patterns will cause trouble and structure your code differently. Most of the time, Rust will catch things that could result in memory or threading issues in other languages, but sometimes, such as our case here, it can't tell whether the operation's okay or not, so it rather errs on the side of safety. You can read more about it in the chapters on ownership and borrowing. Yeah, so the idea is you could have as many... I'm going to make that little change, by the way. So the idea is that you could have as many... references, like immutable references, as you want at the same time, because they don't really cause any issues. It's when you start getting immutable references that multiple things are writing to the same piece of data at the same time. That's why the problem arises. So look at the move by function. We now take an ID and we take the map, and I guess we can work with that. It's a little funky though. I feel like there's a little bit of inconsistency in the tutorial right here because game has map in it, right? Game has map in it. So it's kind of weird that we're passing the map rather... I mean, we'll go for it, I guess, but it's kind of weird. I noticed that a couple times last time as well. Okay, so now we need to do let x, y equal objects id dot position. So we basically get that position out of the object, and then we no longer have the self here. So that should make that happy. X plus dx, y plus dy. Right. Yeah, because we're swapping this to be is blocked as well, so it's changing up a little bit extra. So is blocked. So we'll do that one. X plus dx. A little messy converting the two, but it, you know, it happens. Refactoring can be like that. So now we have both of those. Now we have map, objects, and then we do, this is part of the reason we wanted to do the that method before. So objects id dot set position. And everything there is happy now, but where we're actually calling it's not happy. So we'll get around to that in a minute. Go back to the browser. So all's well. So after this interlude, the objects, including the player, can no longer move into a tile occupied by another blocking object. Next, make sure we don't place two blocking objects onto the same tile. In place objects, we'll check whether the tile's free before placing a new monster. So... okay, I'll read ahead a little bit here and then we'll do a few things at once. So we're going to modify it. We're going to add that is block check. That means we now have to pass the map to place objects as well. And of course we have to pass map when we call place objects in Makemap 2. Since objects have two new properties, we need to pass them along to any code that creates one, update the player creation 2, and update the code that creates the monsters. So there we are there. Let's make the monsters alive as well right before pushing the monster in, set the alive. And in handle keys, we'll change the movement code from player.moveBy from the old one basically to the new one. Except they're passing game instead of objects. So I'm gonna do this, and we're gonna have to go modify that other function signature as well. Because there's a little bit of inconsistency there. That's what I'm here for. Here to call out those little inconsistencies. So the first one is in place objects. Where, oh, where is place objects? Go to definition. And only play. Okay, so we'll check whether the tile's free before placing a new monster. Doesn't really say where they're putting it though. And I want to make sure. I guess, are they just going to throw it away? Or are they going to So what I'm interested in is this. So only place it if the tile is not blocked. And then we do if not is blocked. XY map objects. And then basically everything in here goes inside of that. Cannot find map, I know. So then we need room rect, and then we need map. And we need objects, which we got. So what I find interesting is we're not regenerating these values. So if X and Y fail, then we just throw it away. So it might mean that we end up missing an occasional monster or whatever, but it's probably not that big of a deal in the long run. And of course we have to pass the map when we call place objects in Makemap 2. So place objects. So new room map and map. And since objects have two new properties, we need to pass them along to any code. So object new. So we're going to call this an orc. We're going to call this a troll. And then we want to set both of those true for the, what property is for blocking? If I can type. That's for their blocking property. And then right before we do this, we say monster.alive. Isn't it? Still true. Why is that mad? What did I do wrong? X, Y, O, orc, that. Oh, I see. I missed I did it on both of them somehow. Oh my god. Oh my god, I cannot type. I'm doing weird things with my hands here, okay? That sounded wrong. It's all good. So we made that happy. Let's go to the only other instance of that, making the player. And right after the character, it's going to be player, and then true, and then player.alive, because the player is alive, I guess. And then, yep, we've done that. Monster, okay, cool. And handle keys, we'll have to change the movement code, which I think might be, that's what it's complaining about over here. So 0, -1, game, and objects. Oh, actually, no, we didn't have to change any other. We didn't have to change anything else, so we're good. We're passing the map in is fine. Oh, here we're still taking, okay. Here we're still taking this, and they didn't mention it. Move by player. Actually, hang on. Player. See, refactoring can be a bit of a pain. And I guess my problem I have here is that it's a little harder to refactor someone else's code. So instead of passing in player, we pass in all the objects. Did we do handle keys anywhere else? It's going to be mentioned later, I see. Yeah, we need to fix the signature here. So it's going to be objects. There we go. What did I do? Oh. I left the player one there. Okay, and then this is no longer player.moveBy. Just move by, right? Is it actually object move by? Let me double check. Oh, when they said turn it into a plain function. Okay, we need to move this out of the, well, there's two ways to do this. It looks like they wanted to move it out of object. You could have left it in object, but then you have to do object double colon move by, which I actually think might be a little bit of a better approach, if I'm being honest. Okay, and then it wanted the map here. So let me see. And see, they're passing the game in, so I am gonna switch this to... It's tough. It's tough to decide what's better. I'll just go ahead and do it this way. Get those references on there. I could have edited all 4 lines at once if I were being smarter. Okay. What's mad down here? Handle keys. Takes the player, so it's objects. Here we are. Now everything's almost happy. Player's not mutable. Yeah, we gotta change that, of course. All right. Nope. There's still things up here that are mad. Yeah, this is no longer private type tile. Can't leave private type. Yeah, we're good. We need to remove that since we took it out of the object impl. Now, that was a lot. Let's go ahead and just run this real quick and take a look at it. So we have 2 orcs in the room. And I can't move through them. I'm hitting up. You can hopefully hear me hitting up as I'm talking. Hitting left. So yeah, we have some orcs. Let's see if we have a troll anywhere. What is this map? There's a troll. They have a 20% chance, so we should expect to see mostly orcs. Which we have. We've only seen 1 troll so far. Lots and lots of orcs. It's very unlikely that you're going to have 2 things spawn on the same place, but it is possible. So it's very rare that you would have to throw away one of the monsters you've generated. So I guess it's okay. All right, cool. We've uncovered the map. See, there's monsters. They don't show up in our field of view, which is nice. Like, or they only show up when it's in our field of view, which is nice. It's exactly what we wanted. So yeah, we're doing good, right? Let's move the browser back over here and let's read on. There's a little bit of a rough refactor there, but I think we're in good shape, right? Okay, so we've done all that cool stuff. Player actions are next. So last stop before we get to the actual combat system. Our input system has a fatal flaw. Player actions, movement, combat, and other keys, full screen, other options are handled the same way. We need to separate them. This way, if the player pauses or dies, he can't move or fight, but can press other keys. We also want to know if the player's input means he finished his turn or not. Changing to full screen shouldn't count as a turn. I know they're just simple details, but the game would be incredibly annoying without them. Let's define high-level actions from the player that we can control in the game loop. with this player action enum. Okay, we'll derive some partial EQ so we can do comparisons with them. And we're going to be using those in handle keys. So handle keys is actually going to return a player action instead of a Boolean. And then we're going to be using the enum values heavily in handle keys, so let's just import them in the top of the function rather than having to type them out every time, rather than having to type player action every time. And in the code for full screen, return didn't take turn. Have escape, return exit, same as always. And player action took turn to all the movement actions, and player didn't take turn to catch all the end, to catch all at the end. Okay, so all this is going to ensure that pressing an unknown key will not do anything, and as we'll add other actions such as picking up items, accessing inventory, etc., we'll have an easy way of saying whether they take a turn or not, or even being more dynamic than that, just opening an inventory may not cost anything, but using an item from it could. And now let's only allow things like movement when the game is still going on. You wouldn't want the player's corpse to walk around after death, or maybe you would, there's a game idea. But you may still allow things like full screen exiting the game or even a read-only view into the inventory. So yeah, we'll look into all that. Let's go ahead and start implementing these things. We need the enum first and foremost. Let's come up here to the top. And do I have another enum somewhere? I thought I did. We'll just slap it somewhere in here. So this is where, you know, one of the downfalls of this that was mentioned is that it's all in one file, and that's not really something that you would want to do. The program is not going to be too large, but it would be kind of nice to separate some of this out to make it a little more readable. It's getting a little messy already, in my opinion, because we have so many different enums and structs and impls and functions and stuff that it's really hard to find what's related to what. So we'll definitely keep that in mind, that this is not like necessarily the best way to architect your to manage like your files and your functions and stuff here. But that was known from the start, right? The tutorial itself called that out. So fn handle. So now you return a player action, and then at the top of that we're going to say use player action double colon star, and then escape returns exit. It is exit, right? Yeah. Escape returns exit, and then this here at the end should simply return didn't take turn. Let's see. All right, we're doing it a little bit differently now. So let's take this here. I think we're gonna slap. I think I know what we're about to do. Are we slapping the return onto the match? I think we could do this here. Return, and then we do the match. Alt enter on full screen. So then this will also return exit. Or no, not exit. My bad. Didn't take turn. Match arms having. Yeah, we're working on that. Calm down. So then this here doesn't return anything, but what we need to do is actually. Oh wait, let's do a multi-line edit. Watch this. You and you and you and you. We need to put that there. We need to go to the end. And then we'll just say took turn. Okay, so now we've slapped the return onto the match, and we just basically feed that value out of, feed that value from whatever match arm we're in, and it bubbles back up to there. So we can actually get rid of the exit here, and it's a little bit cleaner. They do say return exit on there. No, they don't. Never mind. Yeah, so I don't know if they made it clear that that's how they're doing it with the match statement, but seems fine. Okay, so then the other thing we want to do is, yeah, so let's only allow movement when the game is still going on, which we just read a minute ago. You wouldn't want the player's corpse to move around while they're dead. So we're going to update the match to include player alive as well. Also, one moment. I got a bad sneeze building. Hang on. It's like, just happen, right? Just get it over with. All right, let me get a drink of water too. Okay, so where's this wait for key press and stuff? Let's see. Yeah, so let key, okay, all that good stuff. Let player alive equal objects player dot alive. And then we're also going to put, okay, so we're getting a little funky here. So key dot text player alive. So now our match statements have gone a little funkier. Okay. So let's go ahead and switch back to the browser so we can explain what's happening here. So yeah, we just added this. So our match statement now includes three different things. We've added key.text. It's a method that lets us read a textual representation of the key pressed. This will be helpful for when we want to handle letters or keys such as the greater than symbol. The position of these depends on the keyboard layout our player is set up. We can't just check for Shift plus because many non-English keyboards have the greater than key in a completely different place. So we'll pass the text in alongside the key and the player alive and just ignore it for now. So now instead of just matching on the key alone, we have to take these two values into consideration as well. Full screen and exit on escape should work whether the player is alive or dead, so change them to, and we have our example here. We're taking three values into tuple and now ignoring the latter two. So for movement, we want it to only work when the player is alive. So we have the example here. It says there are other ways to handle this. We could use the if syntax in the match arm. So example, key code down if game state equal playing, then move player, or even get rid of match entirely and use if else statements just like in Python. However, I find this easier to read and it makes sure we never forget to handle the game state we have when we add a new key. And now we need to go back to the main loop and handle player action there. So we'll change the end of the main loop to this example here, which we'll see in just a moment when I type it. So let's go ahead and make this make this happy because there's a lot going on here. So for this one here, this is already good for the key, but then we also have a couple of those bad boys right there. And why is it mad? What am I missing? Oh, because it's a tuple. Right. It's a tuple. So we got to surround all that like that. Don't give me a matching. So then for these, they're all going to be the same basically. So let's go ahead and multi-line edit them. And they're going to be, go to the end here and we'll skip one and then we'll say true. And then for this, we ignore both. Full screen is cool, but you're not going to see me use it again because it really broke my scaling last time as it resized the whole screen. So we're just going to, it works. We're going to accept that it works, but we're not going to be using it anymore. So now we need to go back to the, we're going back to the main loop. So instead of if exit, that's no longer how we're actually, what we're getting back. So we're going to rename this to player action. And then if player action exit. There we go. We made it happy now. So functionally, nothing should have changed, right? In terms of from the player's side of things. Functionally, nothing should have really changed. We should still be able to move around, just as before. I can still hit exit and it closes, or escape and it closes the game. So we're in good shape there, but we made it more extensible in the code, which is the purpose of that. So let's come back over here now and actually start getting into what people want to see when they're making a game. This is like the first thing everybody wants is fighting, right? Fighting orderly. This part is already running long, so we won't actually implement combat here. Womp womp. Hold on. Hold on. No, but I mean, I kind of knew that was coming because I looked ahead, but it was worth it. But we're almost done with this part. You see the scroll bar on the side. We're at the bottom, basically. This part's already running long, so we won't actually implement combat here. That will happen in the next part. But we'll make sure that the player and the monsters take turns to act. Also, the other spoiler was that this chapter was called Preparing for Combat, not Combat, right? That was the other spoiler. Preparing for combat. And then going berserk as the combat. So, yeah, we're going to make sure the player and the monsters take turns to act. So, where do we do that? Is that in the main loop? It's not entirely clear. I think it is. So, we'll look through this in a moment here. Let me just read ahead, and then I'll figure out where to implement this, and we'll make sure. But there's something interesting in this code. This here object as *const _. This is to do a pointer comparison. Rust's equality operators, double equal and not equal, test for value equality, but we haven't implemented that for object, and we don't care anyway. We just want to make sure to not process player here. The print line is just the debug message. You'll see it in the console where you write cargo run release to run your game. In the next part, we'll add an AI routine to move and attack, and later on an in-game message log where we can print stuff to the player. Right now, when a player tries to move or bump into a monster, nothing happens. Let's interpret that as an attack. We'll add a new function called player move or attack and use it instead of move by and handle keys. So we got a few things going on here. So yeah, let's go ahead and get this set up here in the main loop, because I think that's where they want it. They don't actually say. But let's go ahead and get this set up. Yeah, okay, that's it. So it's right after that, because we check the player action and then we say let monsters take their turn. If objects player, so if the player's alive and player action is not that the player didn't take a turn. Whoops. So that means the player did take a turn, or we didn't exit or something, right? So it actually says that the player took a turn. I'm wondering if there's a reason we're not checking explicitly for player took turn. Well, whatever. So we're gonna loop through the we're gonna loop through all the objects, and if the object is not the player, I'm also wondering here why we don't do a slice. So we're gonna do that comparison there. So they growl. So what I'm curious about is, could you not do for object in objects, whoops. Could you not do that to loop through all the objects except for the player? Am I wrong? I thought that would work. And then you don't have to check? I'm just gonna go with the tutorial, but hear me out. I think that would work. The world may never know. Okay, it's all good. So then, yeah, right now when a player bumps into a monster, nothing happens. I already read through that. So then we want to interpret it as an attack. We'll add a new function called player move or attack and use it instead of move by and handle keys. So we need this new function. We're going to add it like right here. So we get all the objects. We get the game itself. Is the game? Hang on. No, the game just has the map and stuff. Yeah. Okay. Never mind. We're good. Okay. So we want to get the coordinates of whatever's doing the thing, or wherever we're going, rather. All right, so we got our new coordinate, basically, and then we want to see if there's something attackable there. Try to find an attackable object there. So we're going to get its ID from the map, I guess, or from the list of objects, from the array of objects in this case. So objects.iter.position. So I think what we do here, this is one I'm not familiar with, but I think what this does is gets us the index of the thing that matches true. So basically this closure says whatever object we have, check its position, double equal against this tuple here, and then I guess whichever one returns true first. There might be multiple that match in theory if you're going through like a big iterator or something, but in our game we should only have one object that matches. I mean, maybe in terms of like a monster, I mean, we have it defined where only one monster can be in a tile, so yeah, we should never have more than one match. So the first thing that matches will just return that index, right? Yeah, searches for an element in an iterator, returning its index. So that's an interesting way to search and find something. I like that. That's one I'm not familiar with. So we're going to attack if target is found, move otherwise. So what we're doing, we're matching on that because it's returning an option type, so we get a sum or a none, right? So we have some target ID. The blank laughs at your puny efforts to attack him. And then we get that target ID .name. So we're just kind of reaching into that array. And then here, for the none variant, we're just going to move in that direction. Because we already wrote our move function, so it's easy enough to just now fall back on that function. Game.map objects. Boom. So now we move our attack by, and what we need to do is we need to replace all the move by calls to move or attack by. So where is move by? Right here. So move or attack by. What did I call it? Did I typo it? Oh no, I said player. Oh, my bad. I don't know why I was mixing both names. Player move or attack. And then we don't need to pass the player index in. And then it expects game. What is it? DXDY game. It expects game, not map. Okay. Yeah. And game is already a reference, so I can actually get rid of the extra. Yeah, I don't need to reference it again. That was on me earlier. Okay, well, no, it's because I was referencing the map from the game. That's right. Okay, so now we can actually test this out in a moment. We're going to read the rest of this lesson first because we're at the very end of it, and then we'll actually get the combat in. Yes, it is an evil enemy tusk. Okay, so we've done all that cool stuff. The position method on an iterator runs a test on each object, and as soon as it finds one, it returns its index in the collection. In our case, a vector of objects. It's possible no match will be found, so it actually returns an option usize here. We then test whether we have found a target at that position, in which case we know its index, and either print out a message or just move into that place. And that's it. Test it out, no one's dealing any damage, but the game now detects when you're trying to attack a monster, and you can see the monsters taking their turns after you. Alrighty. Continue to the next part, but not before we actually check it out, right? So the monsters taking their turns, remember, is just going to be text. Them growling or whatever. So if we look at the bottom there, you see the orc growls, the troll growls, the orc growls. There's actually a bunch that you can't see right now because every monster in the level is currently doing that. But if I move into them, if I scroll up, you can actually see, let me scroll up just a tiny bit more. You can see it right there on the console at the bottom. The orc laughs at your puny efforts to attack him. And I could do it all I want. It's going to say the same thing, but I can go over and do this to the troll as well. And then if we scroll down, we'll see that I'm getting the same message for the troll. And you can see it right there. The troll laughs at your puny efforts to attack him. So it is dynamically populating the names as we expect. That's it. Like, we're attacking, but it's not doing anything interesting yet. There's no health. There's no like real substantive combat. So that's what the next lesson is going to be about, is making this a little bit more interesting and you know, an actual combat system you might want to use. So let's go ahead and do this, because this is where it gets exciting. Going berserk! The components! To-do. There is a to-do in this tutorial. I forgot about that. But talk about composition versus inheritance and how this isn't a real ECS, whatever that means. Yeah, so composition inheritance, that's a whole thing I'm not going to get into. But you hear that with like object-oriented programming and stuff. That's a lot of where you're going to hear about that. And one of the things people tend to say is they favor composition over inheritance. Inheritance is like the big thing in object-oriented programming, but we're not going to go into all that right now, because even the tutorial is not going into it. So anyway, our components will be plain structs with related bits of data and not much else. Each object will have some or all or none of the components attached, and that will drive their behavior. Only things with the fighter component will be able to attack or be attacked, for example. So let's go ahead and create the fighter component. It'll have hit points, max hit points for healing, defense, and attack power. And then next is the component for monster artificial intelligence. For now, it'll not carry any data, but we'll soon remedy that. And then we'll update the object definition to have an optional fighter component and AI component. And then we'll have to update object new to take in to set those to none for now. So the newly created objects will not have components, so we'll have to add them ourselves. So that's kind of what we're going to do. We're going to get to this point where we're adding the one to the player, and I'll go ahead and bounce back to the tutorial after we do that. So also they're lying. You'll need to make player immutable because we're changing. We did that earlier. We had to make it mutable because we were changing it earlier when we said player.alive. But yeah, let's go ahead and get started on these. I am going to go up here near the object because this is a little bit related. So the first thing we're going to do is we're going to do a derive clone and a copy and a debug. I type debug and a partial EQ, combat related properties, and methods, monster, player, NPC, struct fighter. So again, they have max health. It's an I-32 in case you want negative. Health is I-32. Defense, it actually makes sense to have negative health if you want to have the concept of them getting overkilled or whatever. And we have defense and power. So a couple basic stats there. And then we're going to have this derive here for the AI enum. Okay. And it's just a basic variant. So we're saying it can have like a basic AI. That's all we have for the moment. And again, we're going to have it optional for fighter and AI. Not air, AI. Okay, so now object new is angry because we're not assigning anything for that. So right now, these are both none. By default, they're none. We want to explicitly add things. I do actually kind of agree with that, but I don't remember if we're going to do it here, but I think like a builder pattern would be nice. But it's good to be explicit about adding things like that, in my opinion, rather than implicit or you know, just cramming things in without the user necessarily knowing. So then let's go down to where we actually make the player and give them a fighter component. Oh, I should get rid of those because we don't need those anymore. Okay, so player dot fighter sum fighter, and then we just start filling these bad boys in. So we're gonna have 30 health. We'll have 30 max, and we start with full health, and then 2 defense and 5 power. None of this means anything yet because we don't have a combat system in place. So 2 defense, 5 power doesn't really say much because we don't know how those values are used. And that's actually one of the hardest things about designing a combat system. For a little tutorial like this, it's not too big of a deal, but for a robust game, figuring out how your stats and everything work is actually very difficult. That's one of the toughest things about like balancing the system, for whatever that's worth. Because I will say my philosophy is I actually don't like balance. Kind of. I like interesting imbalance like you get in roguelikes, but I like fair systems. So there is still a certain kind of balancing that goes into making a system fair, but I really like that interesting kind of imbalance that you come across in roguelikes where, you know, I was playing Cataclysm the other day, Cataclysm Dark Days Ahead, and I started on a character and like the first zombies I ran across was a Hulk. And he just basically kills me, but that was fun because I'd never seen one before. And he's just like bashing me and I'm flying across the screen and it's like, it was interesting. That's not balanced though, right? That's not something that is necessarily fair because there's no way like you could expect that. There's no way to say, oh, if I walk up here, the first chance I see the enemy, he's already onto me and there's no way I can escape because he's faster than me. I'm on an empty field. Like, again, it's not really balanced. It's not really fair, but it was interesting. And I think there's something to be said for that. But the systems themselves are very consistent and fair, and that's what's important. Anyway, enough of that little tangent. So next, the monsters are going to get a fighter and an AI component. So in place objects where we actually make the monsters, let's go ahead and give them those things. And we're going to give them different stats as well, depending on what they are. So let's just look for troll, because that's the easiest place to find them. Okay, and for the fighter, so orc dot, oh, we need to also make them mutable. So let mute orc equal that. So orc dot fighter equals sum fighter. And once again, what does he have? He has 10 and 10. And his defense is 0 because he sucks. And his power is 3. Okay. And he has an AI. Orc.ai equals sum AI basic. And then we'll return orc here at the end. Now I want to basically do the same thing for the troll, except we're going to rename this to troll. It doesn't really matter because it's just a name, but it probably makes sense to name it something that you could find in your code and reference. And the troll is going to have 16, 16, 1, 4. So he's definitely a little more robust, but remember we made him only spawn 20% of the time, so he's not going to be as frequent. Oh, then we got to add that semicolon there. Sweet. Again, you might want to like a builder pattern or something, and we might actually talk about that in these tutorials, but not a problem, not a concern right now, right? Let's not get ahead of ourselves. So AI, we went through all this trouble and yet nothing happens. Well, let's fix that by actually using our newly minted components. The monsters have been growling for far too long and are ready to fight now. We'll start by creating a function that will cause an object, monster usually, to move towards a position, the player's coordinates usually. Okay, so we're going to make this move towards function, and then we'll add a method on object that will tell us the distance to another target. That's probably going to be, it's Manhattan distance, at least that's what I thought it's called, but it's basically the Pythagorean theorem, a squared plus b squared equals c squared. And then we'll use them to implement some basic behavior, like if the monster's close, it'll attack, otherwise it'll move closer. So let's get started on we'll do the move towards and distance to. And then, we'll probably do AI take turn as well, because I've already read through that. So this one's going to be a little bit beefier, but it's not that big of a deal, so I'll try to break it down as I'm going, as I'm talking, but sometimes it gets a little funky. So let's do move towards, where is it at? Move towards, ID, usize. So we're actually saying, I guess this is the ID of whatever it is that's currently doing the moving. And then the target is, like probably me or something. We'll see. We'll see how it actually gets used. Vector from this object to the target and distance. So when we say vector here, we're not talking about a programming vector, right? So we're saying let dx equal target x minus objects ID dot y or dot x. Why did I say y? I was looking at the wrong line. And then we'll do the same thing for dy here. Okay, so we got the delta between them, right? And then the distance is dx.pow2. So remember, a squared plus b squared plus equals c squared is our Pythagorean theorem. And what we're doing here is you've got some x distance and some y distance. Those are basically two legs of a right triangle. So that gets us our Pythagorean theorem, essentially. And so if we do that and then get the square root, that gets us the actual distance between, the straight line distance between the things, right? So this is something that I believe I also talked about a couple weeks ago when I was talking about vectors themselves. And we even talked about normalizing here as well. So some of this will be familiar if you watched that. All right, so now we do move by ID, dx, dy, map, objects. All right, so move towards is here. So again, we get a vector. We're not building out like an actual vector type like I did before. We're not using vector from Algebra, which, quick aside, I don't think I actually ever showed that, but one thing I did after I built my own vector and all that, I actually replaced it with the one from Algebra. It was super easy. Very few changes to the functions compared to what I named mine. and it just worked. Like it's very nice API. Like I would definitely probably use that if I'm working with my own engine that I'm kind of building up from scratch. Who knows if I'm going to be, or if I'm going to be using like Bevy or something. We'll find that out one day. So we get that vector, we get the distance, use the Pythagorean theorem, and then we normalize, and we round it. So yeah, converting to integer is just to basically restrict it to the map grid. So what they mean by that is the map grid is like tiles. It's not floats. It doesn't make sense to have any partial value. So rounding it helps to get rid of that. But then what we really do is we convert it back to an integer because we rounded it. So we already have like 1.0 or 2.0 or 3.0 or whatever. So we just convert that back to an integer, to an I32. So the other thing we need is distance 2. That's actually an object. It's taking a self. So I was like, wait a minute, something's not right. Simple object, distance 2, and it's taking a reference to itself. And another, we got another object coming in. F32, let dx equal other.x minus self.x. Let dy equal other.y minus self.y. x.power 2, not 20, plus dy.pow 2 as F32. Squirt, and we'll just get that returned. So yeah, and then the idea was let's use those to implement some basic behavior. So we need this AI take turn function. I'm going to go back down to right before main, and we'll implement that. So we have the monster ID, which is a usize, so that's going to index us into the vector, I'm assuming. Objecty. Okay, so this is a basic monster takes its turn. If you can see it, it can see you. So let monster X, monster Y, will objects monster ID dot position. Okay, yeah, so we're just yanking out the position from the monster. If tcod dot FOV dot is in FOV, so yeah, we're just checking, can we see each other? Can we see each other? That's all we care about, right? So if that's the case, then we want to check how close they are. So we're going to do objects monster ID dot distance to objects player. I like this approach, however, because what we do is we first rule out, can we even see it? If we can't see it, doesn't really matter. Skip the rest of the processing. So that's a good start. I like that. If it's 2 or more away, then we move towards the player. Move towards the player far away. Let player X, player Y equal objects player dot position. And this is where we're going to make use of what we just did. Move towards, because we get that vector and normalize it and everything. So it basically, that's getting us a direction, right? That's the point of like normalizing the vector. Well, that's the point of getting the distance. Like, okay, how do I say this? So that's the point of getting that distance and then normalizing the X and Y values with respect to that distance. That's what tells us basically move 1 square that way and 1 square that way, or just move 1 square that way only. That's what breaks down the components and just tells us, even if we're 15 squares away, you can only move 1, right? So that's the point of doing that normalization. Not the best explanation there. Go back to the vector thing I did a couple weeks ago. And it would probably make more sense after watching that. So we're gonna do a map or else, or no, a map or. Default value is false. And, oh no. Go. And then so here we are close enough. Attack if the player is still alive. So let's break down how this closure and stuff works. I'll go ahead and type out this last bit here first. Print line. The attack of the blank bounces off of your shiny metal armor. Because they suck. Okay. So let's break down this closure and stuff. So if it's in the field of view, if it's 2 or more away, move closer. Otherwise, if it's close enough to attack, then we want to check okay, yeah, what we're doing here is we're getting the fighter component from the player, and we're doing this map or on it. And that basically says returns the provided default result if none, or applies a function to the contained value if any. So that's because it's an option type. So fighter was an option type, so it could be a none. In that case, just return false. So else if false. Otherwise, it actually returns true if the player's health is more than 0. So it's a little bit funky, but that's how we're checking if the player's alive, by using that map or. And we're saying let monster. We're just grabbing the monster based on the ID that we already have. And then it doesn't really hurt us because we haven't factored in health yet. But we have room here now for the monster to hurt us. At least it can try. That's the idea there. And then for any of this to have effect, we need to call it from the main loop. So let's go down there. And it's going to be in the monster taking their turn bit. So instead of them growling, we're going to replace that with the AI take turn. It's going to be ID, tcod, game, and mute objects. Except for ID. Okay, we changed this a little bit. Okay. I'm still interested in something on the way they do it, but I'll accept it for now. For ID in 0 to objects.len. I'm still a little confused about why we're doing this way. We could definitely loop through where we know it's just looping everything that's not the player as well. But we're going to check the object ID and the AI is some. So this part does make sense. We do need to check if it has AI, because you don't want like a scroll, unless the scroll has AI, you don't want the scroll taking a turn. So yeah, when we test it out, we should see monsters following us and doing stuff, trying to hurt us. So let's give it a go, right? No one in the starting room. Cool. Broke the monsters. Wait. There we are. I was like, did we actually? What's going on? So yeah, you see the log filling up, that it's bouncing off my armor, but they're following me. Like they have AI now, right? They do things. So that's pretty cool, right? No need to do this anymore right now, I guess. So let's go ahead and quit, because it's not really affecting us as a player. It's not affecting our stats or anything yet. All right. Sword fighting. The quest for some epic medieval combat's coming to an end. We will now write the actual functions to attack and take damage and replace those silly placeholders with the meaty stuff. The meaty stuff is deliberately simple. This is so you can easily change it with your own damage system, whatever it may be. All right, so we have a take damage function. And then in the next section, we'll modify it to also handle deaths. And we're also going to have the method to attack another object. So we're going to do this take damage and attack function. And it looks like attack is going to be using take damage as well. So take damage is, it doesn't specify this very clearly, but this is, we see it's an unmute self. And I can notice here target.takeDamage, and target is an object. So this needs to be in the impl block, as does this, because this is an unmute self as well. So they're both in the impl block for object. So let's go ahead and make sure we put those in the right place before I start typing and then be like, wait a minute, what's wrong here? Impl for object. And let's go ahead and do take damage. See, this is something that I didn't understand when I did this the first time. I didn't really understand as much about impl blocks and stuff. I was really new to Rust. So some of this probably confused me back then. And now it's like, nah, I got this. We're doing the funky if let block. But it's actually cool. This is a really simple function. And that's what it was supposed to be. But basically, if let, it's a shortcut to say, get this fighter thing out of here. Like, if there is something, if there is some fighter, basically, is what we're trying to say, then go ahead and, yeah, wait, let me try to break this down better. I always read it backwards. This is funky, and I need to learn this better. So we say self.fighter.asMute. Get this here, but it's an option. So we say, if that option is a sum, then get us the fighter component from it. And this is the fighter component that we referenced right here and say fighter.hp minus equal damage. Okay. If the damage is greater than 0. Okay. It's a little funky. I still got to get used to using that because it's a cool construct, but I don't use it very often. So now let's do the other function here to actually attack. And again, we're going to be using the one we just wrote to take damage because that kind of makes sense. So it's a simple formula for attack damage. So we're going to do a map or, which is the same thing where we provide a default. So what we're saying here is for these two components here, yeah, so for the self fighter component, if there is a component, we get the power back. If there's not a component, we get 0. And then for the target, we get the defense. So then the resulting damage is the attacker's power minus the target's defense. Okay. If damage is greater than 0, I think the target takes some damage. Print line. All right, so so-and-so attacks so-and-so for so-and-so hit points. Self.name, target.name, damage. And we need another line here to actually do the damage. Target.take damage. Now, otherwise, if the damage was less than 0, crit line, blank attacks, blank, but it has no effect. And there we have it. So let's click back over. So this calls the previous method in order to handle taking damage. We separated attacks and damage because you might want an event like a poison or a trap to directly damage an object by some amount without going through the attack damage formula. Let's replace the dummy attack message in AI take turn with the call to the attack monster. Alas, the ownership rears its head again. If you just tried the straightforward bit here with monster, so we're basically grab the monster out of the objects and then try to also grab the player out of the objects. We have two different things competing and it's not happy. You'll get another error about a double mutable borrow. While taking two mutable pointers into the objects list is safe when they're pointing at different objects, it would be a problem if they borrow the same one. Remember, you can only have one mutable borrow to an object at a time. Unfortunately, Rust can't just figure out that the monster and player are different items in the list. However, we can let it know. There's a method on slices called split at mute, which takes an index and returns two mutable slices split by the index. And we can use that to return a mutable borrow to our object from both. So split at mute, and I've done this to cool effect before, just a few weeks ago actually, when I was messing with the physics stuff from some of the little SDL things I was doing. I wanted to do collision, and I wanted two objects to be able to affect each other from the same list. Split at mute was the way that I did that. So this is going to be really cool. It's really powerful. So we're going to go ahead and implement these changes here. This was a little confusing the first time I did it, so don't be worried if it is confusing to you, but it's super powerful. Try to make sure I explain it as well if I think there's something I can add to it. So we're going to mutably borrow two separate elements from the given slice. Oops, panics when the indexes are equal or out of bounds. I don't know if I like panic, but sure. We could maybe, instead of panic, return a result or something. So it's mute2, we're making it a generic. First index is a usize. Second index is a usize. Items and mute t. So this actually works for any slice, which is actually nice. Assert first index not equal second index. So that's where the panic is gonna, that's where the panic is gonna happen initially. Oops, I misspelled assert. Basically, assert says, hey, this has to be the case. This has to be true. First index cannot be equal to second index. Otherwise, panic. And these are the kind of things that you would put in. This is in like C as well. Assertions are just a way to kind of, you usually see like debug assertions, and then you would kind of get rid of them in a production code base. But they're helpful to kind of build in some testing, if you will. That's the right term for it. But you can straight up use assertions for tests as well. You run some test cases, have asserts in it. That's basically what test cases are. But you can get way more in-depth on all that. So we're going to compare, find out which index is larger. But first slice, second slice, and then we just split at that whichever larger index is. So items dot split at mute. Yeah, and again, the first time when I did this tutorial, I know this confused me a bit. So I'll probably run through this a little bit and break it down too. It's going to help me because I've only done this a couple times myself, but I do understand it better now, since I did just use it a couple weeks ago. Second slice is there. Okay, else. Second slice, 0. Yeah, this all makes sense to me right now. So we'll break it down a little bit. Alrighty. So yeah, I know it's not used. That's fine. So let's actually read the description of split at mute. Divides one mutable slice into two at an index. So one of the key important things here is where the divide happens. The first list will contain all indices from 0 to the midpoint, excluding mid. The second will actually start from mid and go to the end. So that's the important part, is where the second slice actually starts. It contains that midpoint. So we're actually using that here with the second index to contain that second thing that we want. That's kind of the idea. And that's why we see here second slice, we index at 0, right? Because that's where the split happened. It includes the value. So for second slice, in both cases, we can just do 0. And then for first slice, we actually get that index out of it because we know those indexes are still lined up with where it should be in the split. So if I were to like draw it out a little bit, if we had, just to make sure it's like clear, if we had a thing here of 1, 2, 3, 4, 5, and we split at index 2, then we would have 1, and let's actually start 0. I should have done this instead of redoing all of them, whatever. But let's say we split at index 2, then we would be left with 0 and 1 and 2, 3, 4. So when we say second index 0, we're getting 2, and then if we said like first index 1, we're getting 1 regardless of whether we did the split or not, right? So that's the idea that's going on here, and that's allowing us to have mutable references to two separate slices, or two separate elements here rather, from the same thing at the same time. And it's a way to guarantee the safetiness of doing that, since we know they're not the same thing. All right, so that's a interesting way to do that. I like it. So now we get to modify the monster's attacks. So where was that at? Close enough. Here we are. So instead of this print line of it just bouncing off of us, we get the monster, but we also want to get the player. So we'll just scrap this, most of this line, and we'll get the monster and the player. Mute to monster ID and player objects. Oops, and that went somewhere it wasn't supposed to be. So now we have the monster and the player, and then instead of just the print line, we can say monster attack player. That's it. So we're good. And then the same to the player's dummy attack. So that was back in the handle keys, right? Or no, player, move, or attack. And then instead of this here, we will say, let's see, where do we want to do this? With the target ID? Attack if target found, move otherwise. Yeah, I think it's going to be right here. Let player target equal mute 2, and it's going to be player target. It doesn't really matter what order we do it, by the way, because we put that check in there to see which one is larger. So that's actually a smart way of doing that. But player dot attack target. That actually reads like language. Player attack target. Monster attack player. So yeah, that's it. The player and the monsters. Wait, where did I go? I lost when it resized. I lost it. That's it. The player and the monsters can beat each other silly, but no one will die. We'll take this opportunity to print the player's health so you can see it plummeting to negative values as the monsters attack you. This is how you make a simple GUI. At the end of the render all function, we're going to show the player's stats. So let's go ahead and do that. And then we're probably going to take a look at it. So fn render all. And where do we want to put that? Let's see. Draw all the objects. I guess we want to do it before the blit, right? No, we're doing it on tcod root. Okay. So show the player's stats. tcod.root.set default foreground white if let sum fighter. Okay, so again, just to reiterate this for my own sake, that's saying we're going to get a fighter component from something. In this case, I think it's going to be, I haven't even read it yet. I think it's going to be from the player. And then if it's a sum, get the actual thing out and name it fighter. So I could rename it to potato. That name is just a name. That doesn't actually matter. It's the one over here that matters because it's actually attached to the player. So right here, I could not call that potato, but in here, yeah, unused variable potato, and it's a fighter type. It's a fighter component, a fighter thing. Okay, so yeah, I think I get how that works. So we could also just say none, if let none, yeah. So instead of having to do a match statement, this only happens in the case where it's none, or this only happens in the case where it's some, and we don't have to do a match statement to exhaust both patterns. That's the purpose of that. tcod.root.print ex prints the text at the specified location with an explicit background flag and text alignment. So it's 1 screen height -2 and background flag none. Alignment is left, text alignment left, and then text is format. So we use the format macro. We say HP boom/boom fighter.hp fighter.max HP. Just like that. We now have a little GUI showing up as well. So let's read what it says over here. We render the hit points only when the player has the fighter component. We could use objects player fighter unwrap instead of if let here, but that would crash the game if the player ever stopped being a fighter, which would be a shame. What if they're under a sanctuary spell or some such? So there's actually a reason to think about doing that, which is interesting. Also, the first thing that came to my mind there is what if you also wanted to add a mage component, and then the mage component gives you magic as well. It gives you MP. So you could then only render that if there's MP or something, right? You could make more complex decisions like that. That's the first thing that came to my head. So let's take a look at the game and see it running now with our health being displayed, and we'll see the dudes beat the crap out of us, right? So it's running, and here we go. We see the health in the bottom. Very hard to read, but I've already been attacked. And you can actually see orc attack player for 1 hit points. There, I got attacked a couple more times. And we can see my health is dropping, and it's now 0. So there we are. I want to change that to attacks, because as I saw it, I was like, no, I don't like that. All right, so we can take damage. Everything looks good, right? I think also, let me do something. It's really bothering me. Can I make the screen bigger? How are we? We're doing it from the screen width and height, but it just feels so tiny. Map width and height and everything are based on the screen, right? Or they're not based on the screen, right? They're hard-coded. So if I change one, I have to change the others. Yeah, I don't really feel like doing that. It's hard for me to see on my end. It's a little better if I look at OBS. But that's okay. We'll work with it for now. Alrighty, let's click back over here to the browser and let's talk about Untimely Deaths. Of course, nobody can lose HP indefinitely. We'll now code the inevitable demise of both the monsters and the player. This is handled by the fighter component, since different objects have different behaviors when killed. The fighter struct must know what function to call when the object dies. This is so that monsters leave corpses behind. The player loses the game, the end-level boss reveals the stairs to the next level, etc. This on-death callback is passed as a parameter when creating a fighter instance. Okay, so we're adding a new component on death, and we're calling it a death callback, which is an enum called death callback, player and monster. So there's different callbacks. And then we're going to do an impl that actually, yeah. So basically we're going to add another field to fighter with that enum. It'll represent the different on-death functions we'll have available. We'll add a method that'll let us call the callback. Okay, and yeah, this is an interesting way to do it. So let's go ahead and start implementing this so I can break it down. I don't want to do too many things at once. So let's go to the fighter and let's add on death callback. And here, we're going to define it. Clone, copy, debug, partial EQ. And it is death callback. This is an interesting way to do it, I think. Enums are very powerful in Rust, more so than most other languages. They're really what you would call algebraic data types. So yeah, we're gonna impl death callback, and that's really interesting to me how you can do an impl block for an enum, because in a language like C, C++, Java, an enum simply represents a number. It's an enumerated type. So an enum maps directly to a number, and that's all it is. But in Rust, it's so much more powerful. It can do so much. So I love it. I use them all the time. I was talking to a friend about it actually, and I was working on some code, and I was curious about a way to like implement something. Whoa, what did I do? Wrong button. I was curious about a way to implement something, and I had an idea that involved an enum, and I was asking him about it. I was like, maybe I could use an enum for this. And he's like, we try to avoid enums. Enums are bad. And I was like, what do you mean? They're like all over in Rust code. And that was the moment where it hit me that Rust is a different paradigm, because he's used to like Java and C, C++ and everything, right? So it's a completely different paradigm compared to, what he's used to. And I'm over here in Rust land where every time you open some code, there's enums, right? Because just, that's how we write it here. So what we're actually doing is we're getting, so typically this idea of a callback was always a little confusing to me, because I distinctly remember the first time I ran across the idea of a callback. It was in like some C code, but it was in university, and I didn't know what they meant by callback. I'd never seen one before. No one explained it, but it's essentially you're defining a function that gets called when something happens. So in this case, callback just says, when we do this callback function on death callback, it does a match here to actually get player death or monster death, and then it actually calls that callback function on the object. So it's a little interesting there. Let's take a look and see how they proceed. So yeah, it checks to see which callback it represents and invokes the right function, player death or monster death. The callback functions take one parameter, the mutable reference to the dying object. This is so we can change its properties on death. We also need to set the callback for every fighter instance. Here's the players. So easy enough. Add an on-death callback, and this is for the monsters. Easy enough. Literally just put that there. Add 2 on-death callbacks. And then, well, let's go ahead and do it first, because that one's really easy. So well, it's mad at something else, but yeah, here we are. So let's go ahead and get it to auto complete that. Death callback monster. And we'll go to right there, so I can just plop that in. Plop. And then down here we've got this, but we'll change it to player. Look at that efficiency with which I do it. Not really. Okay. So, yeah, before we get to writing the concrete callback implementations, let's make sure they actually get triggered when an object dies. We'll do that in take damage rather than attack, because an object may die from causes other than combat, such as a trap, hunger, or poison. So we'll put this at the end of the take damage method. So apply damage if possible, and then check for death. Yeah, okay. Let's go ahead and do that. So apply damage if possible, yep. And then we'll say check for death. Call the death function. If let sum fighter will self.fighter. We don't even need to make it mutable, because we're just checking if it died. If it's less equal to 0, self.alive equal false. Fighter dot on death dot callback self. It's smart enough to know, oh no, because callback is the one on the enum, yeah. And then that's going to call a function once we're inside of there. All right, so let's take a look here. The first if let check looks almost identical to the one that's already there for taking the hit points down. There's a difference, however. It boils down to ownership again. The first if let takes a mutable reference to self.fighter. That means for the duration of that block, we can't take a mutable reference to self because a part of it, fighter, is already borrowed. But we do need a mutable reference to pass it to the on death callback. So while it may seem like we could just fold the callback code into the first if let, we can't, because it would result in the simultaneous borrowing of enmute object and enmute fighter. We do not have the same problem in the second if let because we're not borrowing fighter there. Using self.fighter instead of self.fighter as mute means we just copy the fighter value, but nothing is borrowed at that time. This would also mean that if we made any changes to fighter in the second if let block, they would not appear on the self object. As mentioned before, the ownership rules are generally a good thing, but sometimes they're a bit onerous. Anyway, let's go. I like this opinion just being thrown into the middle of the tutorial. Anyway, let's go implement our player death and monster death callbacks. So notice these are not in an impl block. These are just random functions you can throw wherever you want. But I'm going to throw them near where they are needed, like right here after the impl. Seems like a good place to me. Player death takes a player, which is just a mutable object. Game ended. Print line, you died. For added effect, transform the player into a corpse. Player.care, and it's a %sign. I guess we're all mangled or something, I don't know. Player.color equal dark red. So I like this because it shows that all we're doing is changing the color and character of the thing that's already attached to it, and it's going to just magically draw what it's supposed to, as we expect it to. So then here, monster death, monster and mute object, transform it into a nasty corpse. It doesn't block, can't be attacked, and doesn't move. So print line is dead. Monster.care equals, I don't know if I like it being the % sign as well, because I don't know. It doesn't matter, because if you're still alive, you know you're not going to mix up what you're looking at on the screen, right? So it blocks no more, so it's false. Excuse me. Fighter component is now none because it can't fight. AI component is now none because it's dead. It has no AI. And then its name is now changed to remains of whatever it was previously called. Okay. Notice that the monster's components were disabled, so it doesn't run any AI functions and can no longer be attacked. To enable those behaviors, pass the on-death field into the fighter components wherever you've defined them. Rust will complain if you don't, so let the compiler guide you. You can test play around with it now, and you'll see that the player and monsters stop moving when they die. There are some glitches we need to fix, however, so let's not worry about those for the moment. Do we not already... I thought we already set things. Let's just try running it and see what happens. I want to point something out that I really like about the way we have it set up. Oh yeah. We're killing them all right. I can't move over the body. I'm attacking the remains. I think that's the bug. I think that's one of the bugs we're going to deal with. That's cool. We're going to do this until I die, because I know I'm going to die soon. What's my health? Oh, I'm like pretty much dead. So why does my health say 1 of 300? It should be 30. I saw that earlier. Unless I made a typo somewhere, but I don't think I did. See, now it says 30 again. So there's some weirdness going on with that. Like right now it says 30 of 30. I think when I get to single digits is where it goes wonky. Yeah. Interesting. Okay, we'll maybe figure that out over time. Alrighty, so what I want to take a look at and point out is the death callback. Player death is a function. We can just pass that, we can just do whatever we want with that function. So this is something I haven't messed with a lot in Rust, but if I let test equal, what was it called? Makemap. It's a function now. We can store functions like that anywhere we want. Very simple. You could do that in C, but in C you would do like, wouldn't it be star to the? It's a void pointer to the function, so it'd be like void star my function equal star my function. Something like that. I don't remember. Yeah, I don't really do that in C. You could do that. It's not unique to Rust, but I really like how simple it is in Rust. Like, you don't have to worry about any weird syntax or anything with it. It's like, hey, functions are things you can use too. This is where you get that feel of a functional programming language, because it treats functions as, I don't know if you would call this first class value. I don't want to try and say things that are not true, but you hear phrases like that. Functions are as first class values, things like that. That matters when you start getting into these more functional languages. Rust has a lot of that flavor to it coming from languages like OCaml. Just want to bring that up because I think it's interesting how simple and easy that is to do. You can do that anywhere you want, all along. And I've done that a couple times, but it's been a long time since I've had a need to do that. But it actually kind of makes sense with some of this stuff. So yeah, we have some glitches. First, we only want to attack an object if it has a fighter component. In player move or attack, change the target to check the following. Alrighty, let's do it. So player move or attack. Attack if target found, move otherwise. So try to find an attackable object there. Target ID objects. Okay, object position is good. We're probably just going to put an and on it, yeah. And I like this too. So object dot fighter dot is sum. And actually, I don't know if it matters. You short circuit if it's not a fighter, so then you don't even need to check the position, but I don't know if checking the position's a big deal or not. It's probably doesn't matter which order you check. So let's go back. IsSum is a method on option that will tell you whether its value is sum without bothering you with the insides. There's also the issue that when the player walks over a corpse, it's sometimes drawn over the player. And the same issue happens when a monster steps on a corpse. We can fix both by sorting the list of objects by their blocks property. Okay, so we're doing that in the draw screen or whatever it's called, I guess. Redraw, I think. So instead of going through the objects list, we clone it into a mutable vector. Render all, yeah, is taking an ampersand object, so it can't change the list directly, nor should it. Then we sort the vector such that all non-blocking objects come before the blocking ones. Since we can't have two blocking objects on the same tile, this will make sure that our player and monsters won't get overwritten by corpses. And we can always make the logic more intricate by changing the closure paths to sort by. Okay, well, let's take a look at what we have first and make that initial change before we get any crazier. So render all. That's not the one I want. Render all. Should do FN. And where do we do that? Near the top? Or draw all objects. It's going to be down here, right? Yeah. So let's see. Let mute to draw. Vec. We're just going to be like, we don't care what's in it. Objects.iter.collect. Actually, that's a great way to use collect. I should do that more. Because usually when I do collect, it makes you specify what you're collecting into. And I always type the type out. Ooh, there's a typo. I'm not going to do the typo. So sort that so that non-blocking come first. To draw dot sort by 01, 02, 01 dot blocks dot CMP. So we're going to compare it to 02 dot blocks. I need to see how the CMP works. And then draw the objects in the list. So we're going to change that to draw. Object in to draw. If tcod.fov their labels are a little bit different, but it should still work. Should still work. Theirs says tcod.map is in FOV. That doesn't seem right. Yeah, so sort by, well, how does compare work? Returns an ordering between self and other. Returns an ordering matching the expression self, operator, other. Okay. Oh, I see. Less, greater, or equal. Okay. And then it just sort by just figures that out. That's nice. It uses the compare to figure it out. Nice. I like that. Okay. Let's go ahead and this. So yeah, instead of going through the objects, we clone it into a mutable vector. Render all is taken out object. So it can't change the list directly. We already read that. So we sort the vector. It says we can always make the logic more intricate by changing the closure paths to sort by. One more thing, since we're only ever rendering objects that are in the field of view, let's filter them out before the sort. That way we'll only sort items that we actually want to draw. So see, it's getting a little more interesting already. And hey, we're at the end of this section too. So grab all the objects and then objects in to draw. Wait, oh no. When I switch monitors, sometimes it scrolls around in weird ways. Okay, there we go. So we'll say objects.iter, and then we'll filter it. I almost type 0 every time I see that. tcod.fov.is in FOV. O.x. O.y. .collect. Why are you mad? Oh. For the filter. Yeah. There we are. So basically we take an iterator over all the objects. We check if they're in the FOV. So we filter them out. And then we collect them. So then down here we don't need this check anymore. Because we already know we're only drawing things in the FOV. All right. So read this. Dude, it scrolled up again. It's finally ready to play, and it actually feels like a game. It's been a long journey since we first printed the @ character, but we've got random dungeons, FOV exploration, enemies, AI, and a true combat system. You can now beat those pesky monsters into a pulp and walk over them. See if you can't finish all of them off before they do the same to you. Well, let's check it out. Let's try to kill some orcs and trolls. Oh my god. Put them all in the same room. Orc is dead. I'm taking a lot of damage. But it's cool. I can walk over their bodies now. I'm not attacking their bodies. So we fixed that. They can hit diagonally and I can't. Okay, yeah, the troll killed me. That's cool though. We got combat. We can kill things. They can kill us. That's good. It's good progress, right? We're not done yet. 2 hours in. We've only done 2 chapters. But let's go to the next chapter. What is it? The GUI. Status bars. All kinds of fun stuff. I think I might need to take a quick bathroom break before I jump into this one. Because... yeah, it's going to be a little while. And I've had to go to the bathroom for a bit. So... let me take a quick bathroom break, and when I get back, we'll pick right up here with status bars and the GUI. We still got another chapter I want to do after this, so we're going to do at least the GUI and items and inventory. We'll probably end up wrapping up there because these are taking a bit, so we'll check that out. Yeah, so I'll be right back in a couple minutes, and we'll pick up from here. I'll give you some music. That moment when you're back, but you're waiting on the song. Tusk says Echo music always fits so well with the animated BRB screen here. Echo music is just good in general. Echo has a great soundtrack. How was that chicken, Tusk? Chicken kicks ass. Not a JPG, a PNG. It really has been that the whole time, Tusk. I know. That happened to me a long time ago. Where the ending screen is like, oh, it's not animated. Is something broken? That happened to me, like, I think before you ever were on my stream. Alright, let's get back to it. You back up in here. Alright, so we left off after finishing up the combat, the initial combat here, preparing for combat and going berserk. So next up, we are going to do the GUI and items and inventory. If time allows, we'll look into spells and range combat, but I'm not sure if it's going to happen. So let's go ahead and start doing status bars. Let's not waste any time there. So anyway, lots of stuff happens under the hood of a game that players don't really appreciate, like the combat mechanics detailed in the last couple of sections. We'll now work on something much more flashy, the graphical user interface. Using the full power of libtcod's true color consoles and a bit of creativity, you can make some truly amazing graphics. You may argue that the limitations of a console actually make it easier to create a polished game rather than if you had the freedom to position per pixel graphics like most other games. We'll start by creating a GUI panel at the bottom of the screen. Of course, you're welcome to change this to suit your taste, but for now it will hold the player's health bar and a colored message log. It's easier to manage GUI windows and panels with an off-screen console for each one, created before the main loop. Let's add another off-screen console to our tcod struct. And then we're going to have a couple constants that we'll define later, it looks like. What's going on, Jaeger? Let's jump, okay, yeah, so we'll jump right to the status bar rendering code, which is fully generic, can be used for experience bars, mana bars, recharge times, dungeon level, you name it. The bar has two parts, one rectangle that changes sizes according to the proportion between the value and the maximum value, and a background rectangle. It just takes a simple formula to calculate that size and a few calls to tcod's rect method for the rectangles. That's a lot. Let's go ahead and get started on getting that into place. So, good thing the initial part here, by the way, I hope you're doing good, Jaeger. Good to see you. The initial part here is going to be in the tcod struct. And it's going to be, what are we calling it? Panel, right after con. So, panel off screen. And then in main, where we initialize tcod, we're going to say panel off screen new, and it uses the screen width and then a new thing, panel height, which we've yet to define. It says we'll define it later, so we'll just wait on that. Okay. And then we have the two parts. The rectangle changes size according to the proportion between the value and the maximum value, so it's going to be a bar, so we'll see how that works. Oops, that's also wrong. Okay, so it's going to be a bar. So we'll need something called render bar. So let's go ahead and make that function here. Render bar. And it's going to take a bunch of things. So it's going to take a panel, which is a mutable reference to an off screen. It's going to take an X, which is we'll see how that's used. I guess it's the position, X and Y, and then the total width is going to be what we use to, like, our max health or whatever, right? So I think we're going to end up calculating a proportion from this, because we can't just say, like, if your health is 30,000, we can't go over 30,000 pixels or anything, right? So we're going to calculate a proportion out of this. So name, value, I32. That's, yeah, and then max, maximum, Maximilian. Bar color, color, back color, color. Okay, that's a lot. So let's work with it. We're gonna just say render a bar, HP, experience, etc. First calculate the width of the bar. Let bar width equal value as F32 slash maximum as F32 times total width as F32 as I32. Now what's all this? What's the point of all that? What we're trying to do is get that that proportion, right? That's the way I interpret this. So we're trying to get that proportion of what the total width of the bar should be. So we use that, we get this value divided by maximum. So it says, like, that's our percentage, right? Part over whole. So if we have 50 health, but our max health is 100, we're at 50%, right? So then we're basically getting that proportion and multiplying it by the total width. So if the total width is 30 wide, then this gives us a final value of 15 in that case where we're at 50% health. So we convert it all back to an I32 because we can't actually use floats. We just need the floats to initially calculate those values. So then we're going to render the background first. Panel.set default background. And it's just back color, whatever that is, because we passed that in as a parameter. And then panel, ooh, I cannot type, dot rect is X, Y, total width, one false background, background flag screen, was it? Yeah. So some of these values, like the background flag, these are things I guess you would really need to read a little bit more about libtcod's documentation to understand how those work. But we're just gonna, it's a black box right now. Now render the bar on top. Panel.set default background. Where's there two of these? Okay, whatever. Bar color. And then if bar width is greater than 0, panel.rect xy bar width, one false, so many, background flag screen once again. Okay, so there we are. Now let's scoot this back here and see what this says. For extra clarity, the actual value and maximum are displayed as text over the bar, along with a caption, health, mana, etc. Put this at the very end of render bar. So let's go ahead and do that. 1 second. Here we go. So let's see. Finally, some centered text with the values. Panel.set default background to white, and then panel.print ex x plus total width divided by 2, or yeah, divided by 2, y, background flag none, text alignment center, and then we do format. So that actually replaces some of the issues I have with the health bar before, where we were getting some weird values. This should fix all those problems now because we're rendering it in a nicer way here in this function that we're making. So we're going to be modifying the main rendering function to use this. So first we'll define a few constants: the height of the panel, position on the screen. It's a bottom panel, so only the Y is needed, and the size of the health bar. We'll also change the map height to 43 to give the panel more room. And at the end of render all, we'll replace the code that shows the player's stats as text with the following code. And it'll reinitialize the panel to black, call the render bar function to display the health, and then show it on the root console. And then we'll have to add the panel to the render all arguments and pass it from main. So we'll take a look at all this. We'll get all this working now, and everything should be all happy. We'll have something much nicer on the screen, right? Right. Let's go ahead and add those constants all the way up to the top. See, this is where it'd be nice to separate some things out into modules or whatever. You know, we're using map height, don't worry, but we don't want to rename it, but we do want to change it by just a tiny bit. So we're going to need const. We're going to say sizes and coordinates relevant for the GUI. Const bar width I32 equal 20. Const panel height I32 equal 7. Const panel Y I32 equals screen height minus panel height. And we'll go all the way, let's see, into render all. Ooh, not quite, but render all. And we would do this at the end of render all, where I was saying, yeah, where I was doing this here for the player's stats. Replace the code that shows the player's stats. Yeah, I think we replace all of this. Yeah, we do. Okay, so prepare to render the GUI panel. tcod.panel.set default background black. tcod.panel.clear. Okay, so we set it to a color, and then we just boom, show the player's stats. Let HP equal objects player dot fighter dot map, or we'll do the same thing for max HP. We're actually just ripping this value out of the fighter struct, basically. So if there is no fighter, we get 0 for free, and then otherwise, we just rip out the values, basically. And then render bar. Bar width, HP, max HP, light red, dark red, or darker red. I mistyped clear. And finally, blit this onto the root console. So tcod panel 00, screen width panel height and mute tcod.root. So we're going from panel to root, 0, panel y, 1.0, and 1.0. There we are. A lot of stuff there, but we are good. Got to add panel to the render all arguments and pass it from main. Ooh, no, we don't. I don't know why they say that, because we don't, because we're panels in tcod and the code is written to say tcod.panel. So that's fine. I don't see why it says that, but we should be good. So let me scoot this over and let's run it. Do we have a better health bar? Yes, and we have a health bar. A nice one. Look at that. It's usable. Much more readable than what was there before, too. But it's usable at a glance. Two rooms intersected very similarly and made that wide tunnel there. I like when that happens. Quirk of the generation. We're almost dead, however. Gonna play until I die. Oof. There's a problem. They're not really smart enough to go around the corners, and I can't corner attack. Look at me caring about this, even though it's not really... Well, damn it, I'm gonna die. It's not super functional yet, but I'm like, no, I want to win. I must kill the orcs and the trolls and stuff. Ah, I'm dead. Rip. Ripperoni. Okay. So now for the message log. Until now, the combat messages were dumped into the standard console. Not very user-friendly. We'll make a nice scrolling message log embedded in the GUI panel and use colored messages so the player can know what happened with a single glance. It'll also feature word wrap. The constants that define the message bar's position and size are these: message X, width, height. This is so it appears to the right of the health bar and fills up the rest of the space. The messages will be stored in a vector so they can be easily manipulated. Each message is a tuple with two fields, the message string and its color. The type of that vector will be vecstring color, so we'll be passing it to a lot of our functions, so let's make an alias for it called messages. Okay, and we'll use two operations on the struct, adding a new message and iterating over all the existing ones. So for convenience, we'll also add a new function so we can create it easily. So we'll do an impl for that messages type that we're about to declare. So let's do all of that. Constants first. I guess I'll put that with these other ones here for the UI. We'll say const message x i32 equal bar width plus, I don't know why I thought that said divided. I was like, that's not how divided symbols look in code. Const message width i32 screen width minus bar width minus 2. Const message height i32 equals what? Nope, it's a usize. It's panel height as usize minus 1. Okay, so then we need a messages struct. Doesn't really matter where I put it. I'll just put it here for fun. Whoops, I need the tuple thing, the parentheses here. Messages. Okay, and then we're going to do the impl block for it real quick. So basically we'll just make an empty one here for our new, whoops. What did I do? Hold on. So I want to call this messages. My bad. Yeah, there we go. Wait, why did that make it happy? What? Hold on. Oh, it was already happy. I think it just didn't refresh. I was like, wait a minute, that shouldn't have fixed anything. Didn't change functionality, I think it just didn't refresh. Add the new message as a tuple with the text and color. I would almost rather do like an enum or something than explicitly pass in a color. Like define a message type and just let that determine what color it is. Maybe there's going to be something like that later, but I don't know. I kind of like that more than just saying color. I don't know. I feel like you could also get a little bit bogged down in terms of too many message types, right? Like, does an attack have a different color than you killing an enemy? I don't know. Create a double-ended iterator, nothing else. Nothing else could be double-ended, don't worry about it. So we're doing some constraints here, which I talked about recently when I was going over vectors and stuff. We did a little bit with constraints, and I had a little bit of issue with it. But this is also different than how I did it before, actually. No, we're not doing constraints. Never mind. I'm sorry, I wasn't paying attention as I was typing. We're returning something that implements that. That's how I'm reading this. This is not a syntax I'm super familiar with. But we're just saying return. That's interesting. Return an impl. We're not saying return a double-ended iterator. We're saying return an impl double-ended iterator. And then we just say, give us an iter, and it figures that out, I guess. We'll see what the description here is, because that's not a syntax I've ever really used, other than when I did this tutorial 2.5 years ago, and I don't remember it. So that one's interesting. So yeah, so we can make a new one. We can add, that's easy enough, and we get the iter of it. So the t into string bit makes the add function generic. That's our constraint, actually, yeah. So that is an actual constraint. We're saying whatever the generic type is has to implement that. Has to be able to do an into string. Instead of accepting a parameter of a specified type, it can work with anything that implements the into trait for string, i.e. anything that can be converted to a string. This lets us pass both ampersand stir and therefore string literals and string, an output of the format macro, among other things. As we're keeping the inner messages field private, we need to provide a way for our users to access the messages. In Rust, this is typically done via iterators. We could try to find the exact type that vec iter returns. It is standard slice iter, and then it's specifying a lifetime of a, and then string color, but that's a bit hairy, so not always desirable. You might prefer to treat the exact iterator type as an implementation detail subject to change, and for more complicated scenarios, example, returning an iterator that has map or filter called on it, completely impossible. Sometimes a function can return a type that you cannot write in your own code. What we can do instead is say this function returns some type implementing this trait and let the compiler figure it out. To do that, you have your function return an impl trait and make sure whatever value you actually return does indeed implement that trait. To show the messages, we go through them one by one, get the height of each, potentially line wrapped, and draw them onto the panel using the print_rect method. So here we go. That'll be before we blit it, I guess. So let's take a look at it. Let's go ahead and try to do that. Where's that at? We'll look for blit. So we'll do the render bar, and we'll say print the game messages one line at a time. Let mute y equal message height as I32. For ref message color in game dot. Okay, this is a weird syntax too. Iter.rev. And this is going to be mad because game does not have messages. So we're going to have to add that as well. Let message height equal tcod.panel.get height rect. And it's going to be message x, y, message width, yes, 0, and then message y minus equal message height. If y is less than 0, break. And then we do tcod.panel.set default foreground to color. tcod.panel.print rect msg x, y, msg width, 0 message. So we're actually we'll take a look at this in a moment. So we're going through the messages backwards, starting with the last message, because we don't know if we get to print all. So first we calculate the height. Okay, yeah, so this is something that here where we do iter.rev, we're reversing the iterator, because you think about it, when you put a message, it goes on the end of the vector, and you want to see the most recent message last. So that's the idea here. So first we calculate the height of the message in case it gets wrapped. We draw it at the corresponding Y position by subtracting the height and then repeat. When we have Y lower than 0, it would mean we'd draw above the panel. libtcod wouldn't let us, but since that means we ran out of space, we may as well break out of the loop. Okay. So I'm interested in the get height rect of the message here, because I don't. So we print rect. Okay, I see. So get height rect. Let's take a look at it real quick. Get height rect just says compute the height of wrapped text. Okay, that's all it is. And then this actually prints that text onto a rectangle, basically. Cool. Works for me. Let's go back. And the original Python tutorial uses the text wrap module in Python standard library to split the text into multiple lines based on the max length. Rust standard library doesn't have such a function, but we can use libtcod's get height rect and print rect to do the wrapping for us. We're going to add the messages type to our game struct rather than adding another type to every function that will want to print a message. Easy enough. And we'll initialize it in main, it should say. But we'll initialize it in main. But now we're ready to test it. Let's print a friendly message before the main loop to welcome the player to our Dungeon of Doom. Alrighty. Well, before we can actually do it, we'll do what they said and initialize it, right? Messages, and then it's going to start complaining down here because we didn't give it messages. Whoops. New, and nothing else really needs to be done there. So before we enter the loop down here, we will say a warm welcome message. Game.messages.add. Is game mutable? I think it already, yeah, it has to be mutable. We're passing it mutably all over the place, right? Welcome, stranger. Prepare to perish in the tombs of the ancient kings. Oh my, I'm spooked out. And it's a red message because it's spooky and evil. Yay, you can now replace all the print line macro uses with calls to our own message function. Well, let's take a look first at what it looks like. Boom. We got the message, But we got nothing else logging, so we'll have to do as it says. But yeah, welcome, stranger. Prepare to perish in the tomb of the ancient... In the tombs. In the tombs of the ancient kings. Alrighty. The tombs of the ancient kings. It's actually, they were all drummers, okay? The ancient kings were drummers, and we just stumbled our way into their drums. That's all. Into their toms. Alright, so, So yeah, we can now replace the print lines. Player death message is red, the monster death is orange, and the rest is white. Unfortunately, display message, we have to pass the messages vector everywhere we want to print a message, which is pretty much everywhere. As usual, just replace the print line calls with message and let the compiler guide you. The end result should look something like this. This is going to take a moment, so let me just go ahead and pound my way through it real quick. So let's look for print line. We'll say message. It was message, yeah. Hold on. No, we don't want to say message. We want to say messages.add. Yeah. We want to say hold on, I'm looking for it. Yeah, it's just going to be game.messages.add like everywhere. So game.messages.add. It's only 4. All right, and we'll have to pass a color in as well. Cannot find game, so we're gonna have to make it happy. Let's see. Attack needs it here at the end. That makes it a bit happier. And then these where they take damage. Takes 2, but 4 were supplied. We format all this. Basically, we do a format here, and then it's going to be white. Same thing here. Okay, that one's happy. Now, what's making this one mad? Player death. All right. There we are. Format. And then this one is red, I think. See, what color is the player death? Red. Monster death is orange. Yeah. Oh, I think death callback's going to need it too. We'll get to it in a minute. So monster death is going to need game as well. And format. Orange. Cool. And then incorrect number of function parameters. So callback would be game. And the callback here needs game and mute game. No? You're lying. Player death needs game. Yep. Oh, I think is it because it's because of down here, right? Yeah. Because I haven't passed it down here yet. Game. And take damage needs it. It's everywhere. I mean, we sorted out one time and it's not too bad though. Okay, so this function takes 1, but 2 were supplied. How? Why? Well, death callback. Where are you at? What am I doing wrong? Object in game. No, that looks right. Player death, monster death, callback, object game. So I seem to be missing something weird here. Cargo build. Let's get some extra info here. Monster.attack. Okay, wait. Here we are. Something down here. Here we are. Yeah. So this needs game. There we are. That makes that a little happier. And then this needs game. Okay. Now, why is this bit still complaining? Callback. Argument unexpected. No, I don't believe you. Incorrect number of function parameters. I gotta take a close look at this and see if I'm doing something wrong. So callback. Self. Mute object. And mute game. Use death callback, yeah. Let callback equal match self. Oh! This is why. I think maybe an auto format or something? Put that type in there. It was specifying the type. Either that or I typed it earlier and I didn't realize it. But the type inference is fine. But it was saying, hey, you told us that it's a function that takes an object, not a function that takes two arguments. So then you're giving me two arguments and I don't know what to do with that. I'm mad. Alrighty. So that should be good. It should be happy now. So yeah, we did a bunch of things. Basically, we added game to the functions arguments. Whichever function number one is up here. Player death. We added it to monster death. We added it to player mover attack. We had to add it into this call to handle keys. I think we already had that. I'm not believing that one. Or is it making it mutable? Whatever it is. Let's see here. We had to add it to AI take turn apparently, or make it mutable. 7 and 8. Mutable to, yeah, okay. Made it mutable here. So there are a couple places where it needs to be mutable, a couple places where it has to be added, and then we had to just basically add multiple messages into the function calls, essentially. What is number 10 real quick? Oh no, that's fine, yeah. So it's a bit of a pain to go through the refactor. It's quite annoying, and you may think about using global variables or the singleton pattern to ease the pain. If you want to go that route, you may check out the lazy static crate, but if you persist a while longer, we'll collapse all these separate variables into 3 structs that are much easier to pass around. Alrighty. Now we'll leave mouse look in a minute here, but first I would like to run and make sure this is actually work. No, there is still some red. I think that's where we need to make a couple things mutable. Cannot borrow game is mutable, yeah. I was like, I don't think I did a couple of those. Differing mutability. And mute game. Are we good now? Cannot compile. Who's mad? Player action equal handle keys. And mute. Now what's mad up here? Yeah, there were definitely a few more things that slipped past. Now I think it's happy. No. I don't, okay, I was like, I don't see the red, but it's so tiny. It's everywhere. No, now it bubbled up here again. You're lying. Game is already mutable. Can I just pass game in? Yeah. I declared it as mutable, so we could just pass it in now. We don't have to do unmute there. Now I don't see red. Okay, we're good. Cargo run. Make sure you're seeing what I'm seeing. Yep. So there we are. There we are. Orc is hitting me. I'm hitting him. The orc is dead. Cool. It's a UI. Just like the one, you know, I've been playing a lot of Cataclysm. Just like that one in Cataclysm. Dark Days Ahead. I mean, kind of. It's a very simple UI compared to that game, but we got our messages there. In Cataclysm, you would be able to pull up the message log as like a full screen thing and scroll through your messages up to a point. So it's the same idea here. Oh, I have 1 health. Am I gonna die? -1 health. Damn. Cool. You died. Alrighty. So we're almost done with this section now. Let's get the browser back up here and take a look at the next little piece on mouse look. That's different. We'll now work some interactivity into our GUI. Roguelikes have a long tradition of using strict keyboard interfaces, and that's nice, but for a couple of tasks, like selecting a tile, the mouse interface is much easier. So we'll implement something like a look command by automatically showing the name of any object the player hovers the mouse with. You could also use it for selecting targets of spells and ranged combat. Of course, this is only a tutorial showing you what you can do, and you may decide to replace this with a traditional look command. Using libtcod, it's very easy to know the position of the mouse, and if there were any clicks, the input check for event function returns information on both keyboard and mouse activity. First, let's import new types for the input module, and then we'll add those fields to our struct for key and mouse. Okay, to our tcod struct. And in the main loop, we'll populate 2 new fields where we initialize the tcod struct. Yeah, so we're just setting them to default, okay. And the default value is whatever the type considers a default value. It's implemented for a lot of primitives, and you derive it for your own types. We'll use it to initialize our values to known states so we don't have to wrap them in an option when nothing happens. All right, and then to fill them up, we use check for event at the beginning of the main loop right before our call to render all. Okay, so that's a lot, so let's get started on that. All the way to the top. And where is tcod? We don't have tcod input yet, so use tcod input self event key mouse. Alrighty. Struct tcod should be pretty close to the top. Key mouse, easy enough. And then now we know it's going to be mad down here where we're initializing it. So let's go ahead and do those 2. Key default, mouse default. Okay, they're not being used yet. So then to fill them up, we use check for event at the beginning of the main loop, right before render all. So where is render all? There it is. Literally do it right before. Match input check for event input mouse or input key press. I find it interesting this is not in the handle. Where is the handle keys? There it is, it's down below. Yeah, I would think you'd want it in like a handle input thing. We'll see how it plays out though. So anyway, we do the match. We say sum event mouse m tcod mouse m sum event key k tcod.key equal k. And then for everything else, just blanket match it to tcod.key default. I don't know why we don't do anything with mouse. Not sure. We'll figure it out, I guess. Oh, it actually says it first thing. Cool. So the default value, yeah, we already saw that. Here we are. Scrolled up on me, I think. We clear the key back to its default state when we don't get a keyboard event back because our handle keys system would treat it as a new key press otherwise. We don't have to clear the mouse because no mouse event means it's right where it was last time. Now, pass the key to handle keys and remove the call to wait for key press. So we do use it in handle keys. Okay. So handle keys, it's coming in tcod already. Made game mutable. What? Okay. Made game mutable. Oh, I understand why, I think. Maybe. Yeah, I do. Okay. And then remove root dot wait for key press. Okay, cool. Let's start looking at this. So render, or no, not render, handle keys. Game is already mutable, right? We did that earlier. And then key is imported redundantly now, so let's get rid of that. Removed root dot wait for key press. Okay, so hold on, I am fighting a sneeze. I've been trying to stall. Hang on. Okay, sorry about that. So we're gonna match on tcod key, right? Yeah, we're gonna match on that, and everything else is good. So then take a quick look here. Next, we'll write a function that lists the names of all objects at the current mouse position. We'll use cx and cy fields of the mouse struct, which are the coordinates of the tile or cell that the mouse is over. Right, so back to here. So we're gonna make just a new function. We'll do it like right above main or something like I always do. Turn a string with the names of all objects under the mouse. Okay, so we get mouse, objects, FOV map. Oh, because we actually want to make sure we can see there. I like that. So let xy equal mouse.cx as i32, mouse.cy as i32. I'm going to create a list with the names of all objects at the mouse's coordinates and in FOV. Names equal objects. Now this is the sexy stuff. Again, I didn't use iterators like this when I first started with Rust. I wrote really bad Rust code. Like really bad Rust code. So I would not have done something cool like this. So I really like seeing this. Obj.x, obj.y. Could do a filter map, but it might be more readable this way in this case because that's a lot going on in the first part, I think. We're also, no, we could do that in a filter map. Sure, we could. Right, there we go, and we do names.join. Join is this weird thing that it's in like so many languages, but it literally just joins things together and uses that as a separator. So we're joining strings and separating them by a comma. So you could have like 6 different strings and it just puts a comma between each one and smooshes them all together. So what do we have? We have an iterator over the objects. We filter them for something that's at the position and in our FOV map. and then we clone the name of the object so we can actually rip that name out, basically, to avoid borrow ship, as I like to call it, borrow ship issues. And we join them all together. So, okay, yeah, that makes sense to me. So let's see this. I mean, you can do whatever, Tusk, but we're doing random maps, so it'd be hard to do that randomly. I mean, well, kind of. You could put parameters on your random generation. Okay, so where are we at? We go through the object under the mouse, gather their names into a vector, and then use join to put them into a string separated by a comma. The render all function can call this to get the string that depends on the mouse's position after rendering the health bar. So you could add logic to your room generation, Tusk, to say like there's a special room that can spawn sometimes, and give it like some percentage or whatever, and have it like be a special shape or whatever. But I mean, we're not set up for anything like that, and I'm just following the tutorial. But you can make whatever you want, right? That's what's cool about programming and game programming and stuff, is that you're telling it what to do, right? So you're in control of what happens. So we're gonna do this after the health bar, which is right here. So let's see, display names of objects under the mouse. tcod.panel.set default foreground light gray. It's GRAY in the US and EY in Europe. But here it uses EY. Background flag, none. Text alignment left. Get names under mouse. tcod.mouse. Objects, that was already right. And tcod.fov map. That's not. Why is that mad? Is it just FOV? Yeah, it's FOV. Why are your names? Oh, no. Okay, yeah. The name's correct over there. It just, that's what we named it in the function, so it defaulted that on the autocomplete. And then we're going to get a but wait. So, yeah, the render all goes through the string, basically, and hold on. Render all function can call this to get the string that depends on the mouse's position after rendering the health bar. Oh, yeah, I see. Yeah. That works. Cool. Okay, then, but wait, if you recall, in a turn-based game, the rendering is done only once per turn. The rest of the time, the game is blocked on wait for key press. During this time, which is most of the time, the code we wrote above would simply not be processed. We switched to a real-time rendering by replacing the wait for key press call in handle keys with the check for event in the main loop. Won't our game stop being turn-based then? It's funny, but surprisingly it won't. Before you question logic itself, let me tell you that we did some changes earlier that had the side effect of enabling this. When the player doesn't take a turn, doesn't press a movement or attack key, handle keys returns a specific player action value didn't take turn. You'll notice that the main loop only allows enemies to take their turns, that the value returned from handle keys is not didn't take turn. The main loop goes on, but the monsters don't move. The only real distinction between a real-time game and a turn-based is that in a turn-based game, the monsters wait until the player moves to make their move. Makes sense. Yep, and I called that out already earlier. I called it out explicitly. So let's do it. And something made the game mad. Oh no. Something made the game really mad. In input.rs. And I don't know where it happened. tcod key t uninitialized, which is invalid. Uh-oh. Set rust backtrace equal 1. Is it just rust backtrace equal 1? That's not right. No, how do we do that? I thought that works. We're not getting any kind of backtrace though. Unless I'm misspelling it. I never remember this. Okay, what is happening? Something weird with the way we're doing the key stuff, right? tcod key. Let me take a look and compare for a moment. Okay, so we have tcod.key equal k. Otherwise, if nothing happened, we set it to default. See any problem with anything there? tcod.key, tcod.key.text. I need to get this backtrace working. Let me take a look at how to get that backtrace working real quick. I've Googled this recently. How to set environment variables in PowerShell. Oh yeah, no wonder. It's a weird syntax. No wonder I was wrong. Okay, let's try this. There we go. Okay. Now I've got some stuff to look at. We got some uninitialized memory going on. Where does it all originate? Line 796? Match on mouse and key press. Now this is interesting because I've done this before and I didn't have an issue like this, so very curious. Why we're getting a crash here. Something with the tuple here. Event mask, input mouse or key press. Is it key? Did it autocomplete? Hang on. Did it autocomplete? Should it be key? Let me double check again on the code over here. I might have auto-completed to something incorrect. No, it says key press on the code. Let me double check though. Yeah, it has mouse and key press. I might copy that entire match real quick. Make sure I didn't make a dumb typo somewhere. We'll run it before I do that. Still getting the same thing. Line 796. It's on the match. All right, back to key press. Yeah, even when I copy theirs in, we get that error on that exact line. 796. Well, this could be a problem. I can do backtrace full, but that might be a bit annoying. Rust backtrace equal full. Oh man. That's a bit much. It's very rare that you have to look at anything like this in Rust. I really don't like that. Where's that 796 I've been seeing? Here it is right here. Something going on with the tuple here that's weird to me. Check for event. And basically we give it flags. So it says event mask. So a mask is often like a bit mask where these flags represent some bits. Right? So we're not actually making a tuple, it's just a function call. But something is freaking it out. Or is it within the match block and it's originating from 796, but it's actually like some of this stuff, like the sum or whatever. Try something drastic real quick. I'm gonna copy the whole thing and just replace mine. Same thing. That's not good. That what if it's, hang on. Release. What if there's an issue with the optimization or something? I don't know. It seems odd, but no. This gives us like very little information in release mode. Well, damn. It attempted to leave, so it's an uninitialized issue. But it should be, did I do something wrong up here? They should both be default. Where are we creating them? Key and mouse are initialized to default, which should mean that they are not uninitialized, right? That's the point. Rust would generally complain if you're actually doing something uninitialized. So whatever this tcod sys tcod key T is, why is that complaining? Okay, we have a mem uninitialized here in the actual source code. So it's being set uninitialized, and then C key state is being used right here. Let's run non-release again to get more info. Yeah, so it's this 193 here. And then that gets us into like the memory. So it's just as 193 where it is being initialized. It just says attempted to leave it uninitialized, which is invalid. 193. I don't really see that we're leaving it uninitialized, right? Let's see. Man, this is weird. This is bizarre. That's stopping us in our tracks. We can't even get back to the game. But it should be... It shouldn't be something where we have to mess with the internals. I mean, I know who they are, Tusk. I don't really know how to answer that, though. I mean, I know who they are. I never know how to answer a question like that. So check for event. It takes in this pointer here. It's an unsafe function too. Where is this function at? Can I go to it? No, tcod event T is elsewhere. Damn it. Oh man. Yeah, it's deprecated, but it's fine because we're using an older library, so that's to be expected. I wonder if... Let me try something odd. Not 2108. No. There's only specific versions, right? Like if I do 2019, that's invalid. Yeah, it's invalid. Because this came out in like 2020, so I wanted to see if maybe the version made a difference. It doesn't seem to. App. So input.rs. That hits us here. No match. Okay, I can't get to that. So I'm not even going to bother with that. But this check, yeah, this check for event. Mem uninitialized. Yeah, we can't get to some of the core Rust components. Okay, so my next step is... we'll actually look for the error. So let's switch back over to the browser and just paste this error in and see what we get. Yeah, that's not great. Enable Google fallback mixing. Just try Google. So there's a bit too much going on here, and some of this doesn't matter. Some of this is specific to me. Here we are. Panic when using check for event. See? We're getting results already. Using Rust Nightly toolchain. Getting the same error using stable. Been able to reproduce this on Linux. There's a warning during compilation. Actually, yeah, what if I just cargo build? Any warnings? No? Switching all uses of uninitialized will hopefully fix this, maybe on a init. Someone can open a fix and they'll merge it. This person made a fix and I don't think it ever actually happened. This person still gets it with maybe on a knit, so that's a potential issue. This person's doing the same tutorial and hitting the same issue, so yeah, it's good. I'm not alone. It's not an issue on my end. For anyone that would like to finish the tutorial as exercise, switching to master branch and cargo worked for me at least for this specific issue. Switching to master seems to resolve the error, but for some odd reason there's occasional input stick. It's like something isn't registering a key release. This person gets the same error. Well, let's try it. Let's see what happens. It's a potential initial solution to, you know, get things moving a little bit. If it's the kind of thing I can just deal with for the tutorial, I'd be okay with it, because I'm not going to be like making a full game out of this, but it depends on how bad the issue potentially is. Cargo run. So far, so good. Okay, we're in. I forgot what the last... Oh, I know what the last change we did was. I was like, what did we even do last? It was the mouse stuff. Yeah, remains of orc. You see it right above the health bar. Cool. If I mouse over me, it says player. Because I'm a player. Alright, we can see orc. We can see troll. If I kill them... You know what I want to kill two things on the same spot and see if we get like a list of multiple things. Alright, it's not going to work. I'm going to die. Okay, whatever. I think we will. Okay, so this is a workaround for now. So they did put a change on the master branch, I guess. But that's not reflected on the cargo project here. So we're pulling it straight from GitHub here. So it's a fix. We wasted a lot of time on that, unfortunately, but sometimes things like that do happen. And this tutorial is a little bit old at this point. It's a couple of years, 2.5 years or so. So it happens. Things can go wrong, right? So we already read all this about taking turns and all that. So we're actually done with this section, which is good. So we're going to go to the next chapter and see how long this is. Placing items. Whatever. We can get through it today. I said I wanted to commit to at least 4. So who cares if I go a little long? So yeah, this is items in inventory. The player gets to collect or borrow items from the dungeon and use them with a neat inventory screen. More items added in the next part. Okay, so let's check it out. Oops, I'm actually on the wrong thing. That's fine, I didn't do anything yet. I literally just read this here. Alrighty, so we're good. Placing items. Now that our GUI is all spiffed up, let's put in some more core roguelike functionality. The inventory. This has been a staple of roguelikes and RPGs for literally decades. It's a way of gating the player's access to some abilities and presents an incentive for exploration. Also, why else would you explore a dungeon if not to haul out as much precious items as you can? We can place some items in each room in pretty much the same way we place monsters at the end of the place objects function. So the general idea here, we choose a random number of items, we choose a random spot for this item, only place it if the tile is not blocked, and I guess we'll manually just make one type of item for now, a healing potion. And so for it to work, we'll define a new constant max room items, and later we'll expand this with a few magic scrolls in addition to the healing potions. This is the spot we'll add any items we want in the game. The healing potions don't have any special components for now, so we'll get to that in a little bit. And then we'll also define an inventory that we're adding to the game struct. And then we'll have to do that in the main function because it's going to be in the game struct and it's not there yet. So we'll have to, it'll bubble around a little bit. So we're going to go ahead and take care of that. Yay, it's working again. It's like, yay, code again. I was like, uh-oh, we got a problem. Are you looking at the code right now? Yes, you are. Ooh, good neck pop. My neck was stiff. Const max room items 32 equal 123. We have 123. No, we're not gonna have 123 items in a single room. What is it in create room or place objects? So place objects. I guess we do it after the monster. We do it before. They're doing it at the end. Okay, so that's fine with me. Choose random number of items. Let num items equal rand thread RNG. Gen range 0 max room items +1. Now remember, we have to do +1 because the range is non-inclusive. The way the gen range function works. So simple right there. So we're just going to loop through however many items we're trying to make. And we'll choose a random spot for the item. Which is going to be another couple calls to gen range. So it's going to be... This is going to be the same thing that we did above, actually. So I could probably just copy this. Is it room? Yeah, it's the exact same thing. Keep in mind another little gotcha here is that we're starting with +1 because, and then we're not doing the +1 on the back end because that accounts for the walls of the room. You don't want to put an item in the walls. I mean, maybe you do, but the initial logic here is that things can only be on the floor. So we'll only place if the tile's not blocked. Not is blocked, X, Y, chromosomes, maps, objects. I don't have to change anything, do I? Create a healing potion. And so all we do is let mute object. So we make our new object here. And it's going to be an exclamation mark. Healing potion. Violet. False. It's not alive. That's what the false is for. Oh no, it's blocking. My bad. Oh, alive was... Yeah, we have to manually set something to be alive. I forgot. Sorry. Sorry. It was slightly off. And we've made our constant, so now I'm going to add the inventory, like we already talked about, to the game struct. So here we have map messages. Now it's an inventory vec of object. Theoretically, we could put orcs in here if we wanted. I mean, that's the weird thing about using object. It feels like very object-oriented kind of program, a little bit. Not entirely, but it feels a little bit object-oriented where you can just put like any object in there. And I kind of like being a little more explicit on what kind of stuff might go into an inventory. But that still is also kind of falling down the rabbit hole a little bit. All right. So we're not going to put anything in it, although you might want to actually start your player out with one item, like one free potion or scroll or something. So yeah, let's get back over here and check it out. So we just did that. So simple enough. The inventory is a list of items and it starts empty. Now the item component, it will hold all data that makes an object behave like an item. For now, that will be just the item type. And see, this is where I think it'd be interesting to make the inventory maybe based on something like a component, if possible, rather than just allowing any kind of object to go in. But I don't know, maybe you want to be able to capture creatures. Just put them in your inventory. So we'll make an enum, an item enum. And to have the item find its way to the player's inventory, we'll have a pick item up function. We'll go ahead and make these two things real quick. Let's see, fighter. Where is it? Ah, there's too many fighters. Oh, I just found it. Okay. We'll make it near that. After the death callback stuff, maybe. I don't know. I mean, it's very loose organization, but it's something. So what we're basically doing is this is another component. So components can be, because the way Rust treats enums as algebraic data types, we can use them for components just like we can use structs. So again, the AI is an enum, but fighter has more data associated with it, and we want that data labeled like max HP, HP, and all that. You know, we could do that here in an enum, right? You could put I32, 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 death, callback. I mean, that's like a bit of a recursive enum, but you get the idea, right? You know what I mean? We could put stuff inside of it. I was basically copying that, and I picked the wrong place to do it. But yeah, we could put data in the enum, but then it's not labeled. So it's a little nicer if you're going to be moving that data around to probably use a struct and label it like that. Okay, so we need to do pick item up. Go down to the good old standby main and do it right before that. Add to the player's inventory and remove from the map. Pick item up. Object ID. USize. Game and mute game. Objects. And mute vec object. Okay, so the first thing we do, if game.inventory.len greater equal 26, then I guess, yeah, we can't pick anything else up. That's what we're setting here. So game.messages.add format your inventory is full, cannot pick up. 26 is an interesting number. Is that how many letters are in, I'm bad at alphabets. Is that how many letters are in the alphabet? Because if so, at least the English alphabet, I should say, right? Because other alphabets have different numbers of letters. Okay, I'm wondering, yeah, something's throwing me off here. Okay, name is resolved now, good. I think it was that was throwing it off. So anyway, what I was thinking is if it's A to Z is 26, typically roguelikes will do that in your inventory where you press a certain letter corresponding to the letter of the item in your inventory. But item equal objects dot map, or no, objects dot swap remove. Now that's one that I don't use like ever, but it looks like it yanks it out of the vector, removes an element from the vector and returns it. The removed element is replaced by the last element of the vector. By the last element? This does not preserve ordering, but it's O of 1. If you need to preserve the element order, use remove instead. So swap remove is a fast way to just yank something out if you don't care about preserving order. I was like, that sounds kind of bad if you like order. So we picked up a thing, item.name. I don't think it'd be too bad to actually preserve order in this case because you're not picking up that many items. Like you're not going to be picking up 800 items per frame or something that's going to be slowing that down by, you know, sorting the vec every time. It's going to be pretty rare that you have to deal with it. All right, so there we have it. Let's swap back over to the browser. So we limit the inventory to 26 items because later in the inventory screen, items will be selected by pressing a key from A to Z, and there are 26 letters. You could overcome this restriction by implementing pages in the inventory or a fancier interface with scroll bars. That'd be a bit harder, so we'll stick to this for now. You could also assign weights to the items and limit the total weight here, as some games do. We're using the swap remove method to take an item out of the vector. We could use remove method instead, but it usually copies more memory and can be a bit slower. All right, so until now, the ID index of each object remained the same throughout the game. This is no longer true. When we move an item into the inventory, it's removed from the object's vector, and some indices, IDs, will change. As a consequence, we cannot store an ID somewhere and expect it to not change. We need to keep that in mind as we write our game. This may not be a trade-off you're willing to make. Having unique, unchanging IDs to objects is useful. You can store the ID as a monster's target and it will keep following it. If the ID persists even in death, you can have things like spells or missiles homing in on a corpse. There are several ways of dealing with this. Your inventory may store an object's index/ID instead of the object itself, but you have to make sure picked up items don't show up on the map, perhaps by having a renderable component or by making the position optional. You can also use a hash table of ID object. That way, even when you do remove objects, you can still look them up by their IDs. So there's a lot of complexity here. Basically, we're taking a pretty simple approach, but we could put more logic behind it to make things way more complex and maybe could be better, could be worse. I mean, it depends on what you want out of it. So we now have an item. We now add item as another component to the object that the object can have. So we'll just do an option item, and we'll add item none to the new method because we default to none and we only add it explicitly. Now we have an item component. You can add it to the healing potion and place objects. So how does the player pick up an item? We'll look at that next. We'll go ahead and add those quick things there. I am really hungry. Just feel like mentioning that. I have walked about 17.5 kilometers today, apparently, and I haven't actually eaten very much. Like, I've eaten probably about 1,000 calories. So, yeah, makes sense, right? Okay. Alrighty, so now, where's the item? So before we push object.item equals some item heal. All right, so we just set that component, and now we're questioning how does the player pick up an item? It's very easy. Just test for another key in the handle keys function. If it's pressed, look for an item under the player and pick it up. The new code goes below the arrow handling and final return didn't take turn line. So we're probably going to check for like G. Yeah, we're going to check for G. And we'll go test it out in a moment. So let's get that in place. So where's handle keys? Now I feel like this is hanging on by a thread after that little bug we ran into a little bit ago. G? Oh, okay, no. Code is text. I see. And then we actually just match on the text. So we're picking up an item. And in order to do that, we'll say the item ID equal objects dot iter dot. Are we gonna do? Yeah, we're gonna do the position thing. So object dot position equal object player position, and it has an item component. So object dot item dot is some. Interestingly, this would only pick up one item. If there are multiple items there, we would not get. So basically, instead of position, you would want to do a filter and then like iter over that filter. If you wanted to say like, oh, there's 5 scrolls here, pick them all up. Or you just hit G 5 times. It's like not a big deal. So pick item up, item ID, game and objects already ready to go. And then lastly, yeah, take turn. I don't know, I'd probably consider picking up an item to be a turn, but the tutorial wills it. We'll go with it. I mean, you know, we're free to make our own decisions, but I just want to kind of follow along with what they do. All right, let's find us an item. Oh, we were on one. We started on one, really? Picked up a healing potion. And now, like, we can't do anything with it, but we picked up a healing potion. If I mouse over it. Yep, healing potion. I don't know why. Oh, wait, are there two there? So I should see multiple. Yeah, remains of orc, remains of orc. Cool. I like that. G. Yep, there were more than one there. Cool. We got hella potions now, but I can't use them. So we probably want to figure out how to use potions next, right? And in order to do that, we need an inventory screen. We now get to what's probably the trickiest part, showing the inventory screen. Since the functionality is tightly bound to the user interface, it's hard to do it without super messy code. That's great, isn't it? To minimize the amount of hacks, we'll define a single function to present a list of options to the player and reuse the hell out of it. We'll start by defining its parameters so we can decide exactly what it's supposed to do. All right, well then, instead of reading on and just saying, I'll do all these like next few code batches at once, let's just go ahead and plop that in. Because it's easy enough to just plop this in and then work along with it a little more closely. Rather than reading ahead and having too many things to loop back on. So it's generic, and it takes an asref stir. Okay, an asref stir, header and stir, options, and T with I32. Excuse me, I32, root, mute root, option usize. Okay. So that's a little confusing. It's a generic function that takes in something that can do asref stir. So something that can be referenced into a string is what I'm gathering. Head is just a string. Options would be your actual menu things. So we're going to build out a list of options, I guess, and then that gets referenced into the string, into the str. We have a width and the root console. Okay. So we're going to use the root console to draw it over the top of everything, I guess. Okay. This function should show a window with a string at the top, the header, which can be the title of the window and or an explanatory text. Say, choose an item to use or choose an item to drop. Following are the options, which are nothing more than a list of strings. For instance, the names of the items. We also need to define the window's width. The height is implicit, since it depends on the header height and number of options. A letter will be shown next to each option, A, B, ... so you can select it by pressing that key. Finally, the function returns the index of the selected option, starting with 0 or none if the user pressed some other key. We'll start by just displaying the menu and worry about choosing an option later. First, check if there are more options than allowed. Since the menu function is supposed to be reused, it's possible that in the future you'll get too carried away and try to give it more options than the letters from A to Z. It's better to get an early error and fix it than let it slide and get harder to track errors down the line. All right, so we'll add an assert right up here. Assert options.len = 26. You know, I was kind of mad that when I went through school, I never learned about asserts or like really unit testing or anything like that. I mentioned earlier, asserts can be done in C. It's just like a thing that's in C even. And like, come on, C has it? Why did I not learn about this? We started with C in school, you know, and that's how you would do your basic testing. Like it doesn't have to be all of your testing, but asserts can basically be used to build the groundwork of tests. And we never learned about even that. So, I mean, sometimes you might say it's worth just crashing basically if an assert fails, right? Especially if you're doing your initial testing of a program, you know, your homework assignment or something. Like, it would probably make it easier to have developed some of those things by really catching errors very explicitly early on and just straight up failing. I don't know, I'm just on a tangent, but still, it was like, why didn't I learn about stuff like that? I learned about like unit testing in Java when I started my first job, and I was like, oh, this is cool stuff. I like this. And then like a year later or something, I'm like, oh, you could do that all in C. Like, it's not some special job. I mean, Java has great unit testing framework. Don't get me wrong, JUnit's awesome. As much as I don't really like Java, like JUnit is pretty good. Rust has great unit testing framework. But that's all beside the point. It's just random little tangent there. Anyway, so now we calculate the height of the window. It's implicit. The header will be shown using the printRectX function, which can word wrap long sentences so it fits a given width. The number of lines after word wrapping can be calculated with getHeightRect, so the total height is that plus number of options. I'm going to guess this is like the same thing before where Python had some built-in thing for that, but you know, we don't really need to worry about that, right? So yeah, we'll go ahead and add that. We'll look one ahead and say, given the window size, we can create an off-screen console where the window's contents will be drawn first. The header's printed at the top using the auto wrap functionality. So let's get both of these in. So calculate the total height for the header after auto wrap and 1 line per option. So we'll say let header height equal root.get height rect. And it's going to be 0, 0 width screen height and header. So again, the header, it's like using the text to figure some of this stuff out. It's not header. I mistyped it up here. I was like, why do I have head up there? I made that typo. Okay. And then we'll say let height equal, and we get the height from, yeah. So let header height and, okay, yeah, I think that makes sense. Given the window's size, okay, I just read that. So we're gonna make an off-screen console. So create an off-screen console that represents the menu's window. Mute window, go off-screen, new width and height. Print the header with auto wrap. Window. Okay, so just make a console. That's easy enough, right? Can't really say much about that. Here we're going to set the default foreground to white. Here we're going to print rectx, which we've been doing this a few times. So nothing special there. 0, 0, width, height. This background flag is going to be none. Alignment is going to be left aligned. And text is the header. Oof, a lot, and we're not even done. So we're not even on the options yet. We're starting the options now. As it says here, now to the actual options. Printed in a loop, we use the enumerate method on iterator method to get the index for each time we loop through 0, 1, 2, and use it to calculate the y coordinate and the option letter to display next to it. So, and then we're going to do some typecasting and stuff. So let's break this down. So enumerate's always fun. Print all the options. Because if you're new to range-based loops, if you're new to looping in Rust, and you're used to like C loops especially, you're not used to like for blank and blank, if you're not used to stuff like that, you may wonder, well, what if I need to know the index of something that I'm looping through? In C, it's like for I equals 0, I less than something, I plus plus. You might do that in your C for loop. But here you can't do that. And so you're like, well, how would I get the I, the index? Enumerate gives it to you. It gives it to you. It wraps it up in a tuple with the actual thing you're iterating over plus the index. And so we're unpacking that tuple here. So we'll say let menu letter equal b a, oops, plus index as u8. Now that's weird. Those are lifetimes. Those are lifetimes, right? So let's break that down. I guess we have to ensure that these things live long enough. Window.print x 0 header height plus index as I32, not IEW. Background flag none, right? Yep, none. Text alignment left, and once again text mismatch types. No, I get it. You're mad about something. Here, let me just say none for a moment, just to make that happy. So these are lifetimes, right? No, it's not. I'm sorry. I got confused because a lifetime would be like this. Let a test equal thing. If I can type. No? Maybe I'm wrong. I thought that's how you do a lifetime. Oh, wait, no, I know why. Let test A, and then you'd say string, or no, you'd say I32 equal 12, right? Lifetime and trait object must be, okay, yeah. It is a lifetime. I don't have a lot of experience with them in Rust, so I'm just going to kind of back away from that and cower in fear. I have a lot of experience with it. I usually just deal with it when the compiler complains at me. But you see, it does use the, like that right there was a lifetime. Oh my God. Not comma, single quote. It's like single quote A. It could really be anything, by the way. It's a name. I could put ASDF, and that's now a lifetime. So you see, it's complaining ASDF is a lifetime, but the way I'm declaring it's not right. So I can name it whatever I want, but the syntax there is what I'm pointing out. I was thinking about like, oh, wait a minute, what are we doing? Like double lifetimes? No, that is a byte string, kind of, but it's a byte char. Okay, so you could also do something like this, let test equal B, and then this right here, and that's now a byte string. And let's look at let test equal ASDF, and we see the type that we get here is an ampersand string, versus here we get a an array of U8s, or an array of bytes. So we basically did this here by saying this B before the character, we're getting a U8 rather than an actual character. So that's what we're actually doing there. A little funky. That's why I was like, I want to break down what's happening there. So we get that as a character, and then we add the index, or as a byte rather, and then we add the index byte to it, and then we convert all that back to a character. So a little weird, a little funky, but it's there. Now, why are we doing that? So basically what we're doing is we're defining this A as a starting point, which is, what is that, like 45 or something? Or is that capital? I don't remember. Whatever the ASCII value for A is, we're getting the byte value of that, right? The ASCII value for A. And then we add the index of our item onto that. So the first thing we get at position 0 is A. The thing at position 1, we add 1 to A and we get B, right? So we manipulate these values, these ASCII values, and then cast that back into a character. And that's how we get the menu letter. And then we simply just feed that menu letter into our formatted string here. And then we get the option text, which is just the actual item that we're working with, basically, right? So a little funky, but I think hopefully it makes sense. Hopefully. And I think we've already defined that this thing here has to be able to be converted into a string. It has to do that asref string. So that's why we get to just use option text.asref for free, basically. Like, we don't have to worry about anything else because we already defined that. Okay, that was a long explanation, a long like sidetracked there because I wanted to make sure I understood it too, because I thought we were dealing with lifetimes. I was like, wait a minute. So then they're going to explain it too. So let's break it down. We need to do a bit of typecasting here. Rust does not convert numeric types silently, so we need to work with different types. In our case, adding BA, which is how I'm going to pronounce that, which is a U8, and index, which is a U size. We have to convert the type explicitly. You can try to remove the casts as the as type code and see what happens. Yeah, it's going to complain. It's like it'll be you're adding two different things together, and you can't do that. We're going to just kind of let that sit on its own. I'm not going to do that. Okay, all the Windows contents are stored in the off-screen console. It's a simple matter of calling blit to display them on screen. These little formulae calculate what the position of the top left corner of the window should be so that it's centered on the screen. So let's do it, I guess. Okay, so blit the contents of window to the root console. And we'll say let x equals screen width over 2 minus width over 2. Y equals screen. These are ones that like I could take a moment to try to break down how this calculation works, but I almost think it's easier to just like you draw a picture or something and then just kind of like visualize it and, you know, figure it out as you look at it and try to break it down. Because these are kind of things like whenever I'm doing any kind of graphics where I'm specifying things, I usually have to draw some pictures to be able to figure out like how. So it'll be like, okay, I want this to kind of be centered like this and that. I have these values. How do I manipulate the values to get what I want? Right. And again, for me, usually it's like draw a picture or something and really try to get a visual of it, because I don't have a mind's eye. Like I actually don't. I have aphantasia. I'm going to fall back on that. But no, really, I think that does play a role where I can't just like visualize it. So I got to see a picture and kind of work out a little mini formula. So like sometimes they throw these things at you and you're like, where does that come from? Really, you just got to like break down how do you want it to look and then figure out basic ways to manipulate the values you have to turn it into what you want it to look like. And we want it to be like this little centered thing that's not going to take up like the entirety of the screen. So, I mean, I guess we'll talk about it a little bit. So like you have the entire screen width, you get the midpoint of it, and then you take the width of that console and you take half of it. Okay. And then you move it that amount over from the center. I don't know if that makes sense. So let's start from the other side. And let's say the width of the console divided by 2. So we're taking half the width of the console away from the center point of the screen. So that starts it over there. So that means it draws past the center point of the screen and gets the full length of the console. I know it's kind of weird. Again, you almost have to draw a picture out or something. It's hard to explain those kind of things. Maybe I'm just bad at explaining it, so I'm going to stop. And we're also 4 hours, so I want to wrap this bit up before I fall asleep. I'm joking. We're getting there. We're kind of almost done. We're more than halfway. The last two parameters to blit hadn't been used in our game before. According to the libtcod docs, they define the foreground and background transparency respectively. The first is 1.0, so the foreground, the text, is printed fully opaque as usual. But since the second one is a smaller value, what happens is that the off-screen console's background, which is black by default, does not entirely replace the background colors that were previously on the screen. So what you see is a semi-transparent window overlaying the game. As you can see, these neat effects are very easy to do with libtcod. It's not complete though. The screen will be shown for a single frame and then vanish immediately. No, we're gonna wait for, okay. I was gonna say, are we gonna make a new mode? No, this is easier. Okay. I was like, let me just look ahead. It's not, yeah, so we need to stop time until the player makes a choice, and only then can the game carry on. This is easy to do with wait for key press. There's also the need to flush the screen to present the changes before waiting for the input. Righty. So let's see. This is Menu, yeah. This is still all in the menu function. Okay. So then we're going to say present the root console to the player and wait for a key press. Root.flush. Flush that toilet. Oh, his like calling. I don't know, like it's such a funny thing. I remember when I'm first learning C and you learn about flushing the buffer and all that, and just calling it flush to me is kind of amusing. I will say, I actually like C quite a bit. It's been a little while since I've used C. Last time I was teaching someone how to program was in 2020. And back then, I still used C, as even though I was into Rust at that point, I was still pretty new. Like at the start of 2020, I was very newbie in Rust, and I was still writing C like Rust rather than Rust like Rust. So I still use C to teach people back then, and where was I going with that? I got a little lost there because I'm getting thrown off by the characters and stuff here. Oh yeah, but I just remember the first time I was learning all that stuff, and I found a lot of those names amusing and all that. And oh yeah, I was saying I actually do like C, but it's been a while since I've really worked with it. And I don't know that I necessarily want to go back to it, but it is actually very almost elegant in some ways. It's just dealing with all the bugs, the non-safetiness of it. I always take care to write C as safely as I can, but the thing is, people are humans, they make mistakes, so it's nice to have all the built-in features of Rust. You know, that Rust is like telling us, hey dude, this thing here is not safe, you can't do that, or this thing here, this is a problem. Sometimes it feels like the borrow checker is a little aggressive, but it's also like, well, it's doing its job. It's trying to make sure that you're not making mistakes, right? So there is something elegant about it though, because the language spec and everything is so simple, and you can really go through all the basic syntax and everything of C very, very quickly, more so than almost any other language. So it is really nice. But anyway, what we've done here is we flush the root, we wait for key press, and then we check to see if the key is alphabetic, if the printable thing of the key, meaning whatever prints out when you print the key, is an alphabetic thing. And then we convert it to lowercase, because all we care about is lowercase things. So you could type a capital A, it'll still match to a lowercase, basically. And then we check to make sure it's less than however many things we have in our options. And then if so, we get it back. Otherwise, none. So that's a really long function. But if you base most of your interfaces on this function, you won't need to create any more like it. An example, here's how you show an inventory. Just build a list of the items' names, call the menu function. All right, so we're going to try it. So yeah, that was a generic menu, which was, again, kind of ugly and long, but let's see how easy it is to make an inventory now. Because imagine the possibilities here is if we make this big, long, generic function that works for all menus, and then we want to say, well, I'm a wizard and I have a bunch of spells I can cast, right? So what if I want to see a menu of my spells? It's not quite the same as an inventory, right? So you could use the same thing to list out all your magic spells, just as you list out your inventory here. That's the idea. So if the inventory length is 0, then vec inventory is empty. Okay. Else inventory.iter.map item.name.clone collect Fix that typo. I'm trying to see options, how that's going to work out if the inventory is empty. We're still passing it in. We'll see. Let inventory index equal menu, header, and options, inventory width, root. If an item was chosen, return it. Inventory.len is greater than 0. See, in this case, you return the item, but in another case, you might cast a spell, right? You'd probably return it and then use the result elsewhere. You wouldn't probably do it in here. Okay, so inventory width is the only thing. So what I'm curious about is, we put inventory as empty into the options and then pass it in. But then in this function, we would display the options. We would display the options as if they're actually like an item. So I'm confused how that's going to look. Is it not going to present that as an option for us? I think we want to break out of here. I'm not sure. We'll see how they play. See what it does. So we need a constant for inventory width. Let's go ahead and add that. No need to switch over to show them telling us to do it. Inventory width is an I32 equal 50. Alrighty. So it also tells the player if inventory is empty. Simply displaying an empty list would be rude. The constant inventory width is defined at the top as usual. All right, and the header text is a parameter because we want to call this both for using and dropping items, and maybe other actions. Speaking of which, we can define the inventory key right now and handle keys after the code to pick up items. The line break /n after the header gives one line of separation between it and the options. Okay, that makes sense. Finally, the inventory is visible. You can list the items you pick up by pressing I. Selecting them does nothing, though. That's handled in the next section. I mean, I mean, we're almost done, though. We're actually really close to being done. I like it. All right, so we'll go back to handle keys here. And what I'm going to do is I'm going to copy this. And I'm going to get the I from here. And then we're going to replace this with took turn. And we're going to redo this code here. Because this is the unique part now. So we've just swapped out what key we're pressing to I. And then we're going to say show the inventory. And apparently this is taking a turn. Again, I think picking up an item should be, but far be it for me to question the tutorial gods. I think using an item from the inventory should be taking a turn, but merely opening the inventory should not be taking a turn. Alrighty. Root. It's in game, isn't it? Yeah. Game.inventory. tcod.root. There we are. Okay. So let's take a look at the inventory now. Make sure you can see it here in OBS. Okay, yeah, inventory, it does give it as an option, which is a little funky, but it's okay. Let's find us an item to pick up. Stop it. Stop it. So if I try to pick up here, oh, I picked up a healing potion. There was one there. Picked up, can't pick up the corpse. Cool. I can do that and nothing happens because we're not actually using them yet. But okay, cool. Works. And now let's do the last little bit here to be able to use an item, which is actually, yeah, it's going to take a few minutes, but it's not terribly long. Using items. What happens when you use an item? Well, it depends on which item you're talking about. They're all different, so the use behavior of each item must be defined as a different function. Is it going to be like a callback for the item, maybe? We're going to match. Okay, well, we'll see. First, a function that tries to use an item from the inventory and handles things like removing it after use and printing a message when the player changes their mind. Alrighty, so let's do that. It's a bit of a beefier one. It's not terrible, it's just a little beefier looking. Menu, inventory, okay. Oops, I did something wrong. Alrighty, so we got a lot of parameters here. We're taking in inventory ID, tcod, game, objects, got everything here. Yeah, call the use function if defined. So if let some item will game.inventory inventory ID dot item let unuse rather, if I can type it, equal match item heal cast heal. And here's where we don't have a function yet. So it's kind of like a callback, right? So next up, match on use inventory ID tcod. So it actually is what I was suggesting. It's basically a callback, just like we did earlier with the death callback. Use result, used up. Destroy after use, unless it was canceled for some reason. Game.inventory.remove inventory ID. All right, and next up, use result canceled. I wonder if I can have it automatically create used result with multiple uses, or with all the enums that we have. That'd be nice, the variants. Okay, everything looks good there. And then else, it's not like an item we can, yeah, it's not an item we can work with. So game.messages.add format, the blank cannot be used. Game inventory ID dot name white. Okay, and back to the tutorial. We're gonna have to define the enums and stuff. If we do actually have an item, well, yeah, let's break it down. So basically all we're doing is we're checking if it's an item. That's the first thing we care about. If it's an item, get us that item component out of there. And then we want this on use thing. So we're matching against what type of item it is. It's heal in this case. And we want to get the cast heal function, which doesn't exist yet. So it's like a callback thing. And then we're going to match on use inventory ID. So we're calling on use with the inventory ID, tcod, game, and objects. And then we should get a result from that, a use result. It's either used up or canceled. And then we do the appropriate behavior. We either take it out of the inventory or we just put a message that says, hey, you canceled. And then otherwise, that whole thing was in an if, that it's an item. This basically says it's not an item, just say it can't be used. All right, so then if we do actually have an item, we match on its type, that's just heal for now, but we'll soon have more. Find the right function to call for that specific on-use effect and call it. Then based on the result, we either remove the item if it was used up or print a message if it were canceled. So all our on-use functions will return used result. Let's define it. Let's see if I can do that for free. Because it has 2 variants already. Is it smart enough to... No. Damn. You know, I'm too lazy to go anywhere else, so we're going to make it here. Used result, used up, canceled. So now that's happy. And item can either be used up, so we delete it, or the action can be canceled. We'll add a 3rd variant soon. So we're going to add cast heal. I know I didn't switch over for that, but that's literally all it said. So cast heal. Now this has a lot. Inventory, ID. Now this is funky because they're underscoring things, which means that you don't use them. Because if you bring something in that you're not using, it'll complain that it's not being used. But if you put an underscore, it tells the compiler, the linter and all that, rather, to ignore it. Now, this raises questions to me, because the first thing I wonder is, why would you be putting it here if you're not using it in the first place? Well, since it's a tutorial, whatever that was, since it's a tutorial, I'm thinking it's probably because they're going to be used at some point, right? That's my guess. So we'll see what happens. But basically, that's my guess. We want it for later, and they're trying to save us refactoring time by saying, now you can just get rid of the underscore at the beginning and it's already going to work. I hope. So what we're doing is we're getting the... Hold on. Oh, whoops. I said fight. What we're doing is we're getting the fighter component out of the player, and we're going to add some message here. You are already at full health. In that case, where their current health is equal to their max. And we'll return a canceled. And then we'll do game.messages.add. Your wounds start to feel better. Light violet. Now, this is one thing that's a little odd to me, is I understand part of the reasoning behind it, but notice that we didn't do an else. We are basically doing a fallback into the normal workflow. So what I mean is, instead of saying, if your health is max, do this, else do that, we just kind of fall back into that default behavior. There's actually a school of programming, or like a general way that a lot of people like to think about programming in terms of using ifs and else and like cyclomatic complexity, whatever you want to talk about, whatever you want to call this stuff. But there are a lot of people who say don't use else. It's confusing. It's actually better to do a bunch of ifs and have each one do a return, because it's easier to read, and especially if you start nesting them and getting deeper and deeper. So that's just an argument to think about, and probably what they're going for. So we've added this basically again. We get the component out. If your health is already maxed, then we add that as a message to say we're already at full health. Otherwise, and we cancel. Otherwise, we add a message that says we're healing, and we heal by some amount, which is not yet defined, and we give a used up. And if we, in the case where we did not have a fighter component, we go ahead and say it was canceled. So that's it for cast heal. So the heal method itself is pretty simple. And that's going to be part of the fighter component or part of the object? That's part of the object. So it's going to be in the impl block for object. Impl object. So let's put that in here. Heal by the... what's up, Tusk, by the way? All right, so we take mutable reference to ourself, and we take some amount that we're healing, and then if let some ref mute fighter. I need to check that ref there, because I don't really see that much. I think we saw that earlier, and I might have got a little distracted and didn't look as into it as I should have. We'll take a look at that in a moment. So fighter max health, fighter dot HP equal fighter dot max HP. Okay, so it's also if, not it. So ref here, is it just the same as saying ref annotates pattern bindings to make them borrow rather than move? Is it at all different than just an ampersand though? Okay. Ampersand denotes that your pattern expects a reference to an object, hence ampersand is part of said pattern. Ampersand foo matches different objects than foo does. Ref indicates that you want a reference to an unpacked value. It's not matched against foo, ref, foo. Or it's not matched against. Foo, ref, foo matches against the same objects as foo, foo. Okay. That's a little weird, but I think I get it. Okay. All right, so we have a heal function. We don't have a heal amount yet. So let's go up here to throw a constant in because that's what it's being defined as. Const heal amount I32 equal 4. Those are shitty potions. All right, so let's click back over. We're right here at the tail end, but let's recap a couple of these things. So we made the use result, as we already talked about. We made cast heal. I kind of broke that function down already. So we made the heal function, we get the fighter component, and we add the heal amount to it. And then if our health is more than our max health, we set it back down to the max health. So easy enough. The const heal amount's defined at the top, we just did that. And that's it for creating usable items. You can make other items easily by just defining their use function. This could also work for wielding weapons or wearing armor, zapping wands, rubbing a magic lamp, and all that stuff we know and love. Finally, we can now change the code and handle keys to use the selected item. So this is the last little bit that we have to do here. And then we're going to test it out. It's been a long and arduous journey, but we are just about ready to do it. So we open the inventory menu, and hopefully it's going to take into account whether... Yeah, okay, it is. Good. So show the inventory. If an item is selected, use it. Cool. So let inventory index equal inventory menu. And there's going to be all that other stuff that we did before. So let's just slide that down there like that. Okay. If let sum inventory index equal inventory index use item inventory index tcod game objects. Didn't take turn. Confused about something. This is a weird syntax. Oh no, it's an option. We can do that? That's a... I've never seen... I don't think I've seen that particular syntax on... So we're saying Hold on. I need to break down how this works. So inventory index is defined here as an option. It gives us our index. And then we basically are saying if there is an inventory index, give it to us. This is the part that confuses. This is almost like a match statement or something. But using the bracket here, ooh, it's kind of funky. And then what I'm also a little thrown off on is where now we just don't take turns when we use inventory. That's, again, this is based off what they have. So I'm curious why we wouldn't be using a turn. Unless it was baked in here and I've forgotten. Use item. Yeah, no, there's nothing there that... Okay, I might have to break that down a little bit more. I'm not going to do that at the moment, though. So let's look at the last little bit over here. So that's what I just added. We could see that's exactly what they have here. If let sum inventory index equal inventory index. That's a little funky. So I'm going to have to look more into how exactly, like what exactly that syntax is doing. Everything else kind of makes sense, though. And then again, I'm just questioning the reasoning behind didn't take turn. I think what you care about is the result of like whether they used the item or not. And then depending on whether they use the item is what makes you take a turn or not, right? So we'll see. So there you go. The inventory code's complete. Well, minus dropping items. That's fairly easy with the inventory menu, but to keep this from getting long, we'll leave it to the next part. Magic scrolls. That'll really make the most of this inventory system. All right. So head over there and take a look at it. We're in. All right. And pop these dudes. Come on, die troll. Die. Okay, I actually need to heal now, so that's good. All right, I picked up a healing potion. I open this. I press A, and I have 14 health. Beautiful. Your wounds start to feel better. Cool. Where's that other map that I need, that I was on? Okay, there's one. Let's see, where's that other map where there's like 2 healing potions at the start or whatever? Yes, we must heal. We must fight our way through the entirety of the dungeon. I'm gonna die. I don't want to die though. No, I still died. It's okay though. The healing potions work. Combat works. None of that was in the game earlier. All we had at the beginning was a map we could kind of walk our, well, a map we could walk around on, and now we have combat, and we have items and an inventory. So it's definitely becoming much more of a game now. We also have the health bar and the message log too. So it's definitely getting a lot more game-like. So it's good stuff. Let's see. So I had some messages in the chat I was looking at. I saw they were not entirely related, so I didn't want to break into it earlier. Just double checking it real quick though. Alrighty. So that is going to be that for today. Again, I just kind of broke down everything we've done today. So as a quick little aside, let's look at what we're going to do next time. So it might be a bit of a long session next time, which could be a little intense, but I want to do all 5 of these remaining parts. So far we've done 4 parts each time, and they've been 4 and 4.5 hours. So next time might be a little lengthy, but we are going to do spells and ranged combat. We're going to do main menu and saving, dungeon levels and character progression, monster and item progression, and adventure gear. We're going to try and do all that next time, and then next week, when I go to the next roguelike tutorial, it's going to probably, you know, it's going to start from very little from what it looks like. It's a very in-depth, low-level, advanced tutorial from what it looked like to me. I could be wrong, but I've only skimmed it, but it looks really exciting. So I'm gonna have a lot of fun with that. But I'm having a lot of fun with this, and it's so cool to have like a little working game in really not a lot of time. I mean, what we've been on this 8.5 hours, and look what we have. We have something with combat inventory. Like, it'd be really easy to have more, and if I weren't talking and stuff, it would go a lot faster. You know, talking and going back and forth and trying to explain things is what makes it take more time. So, I mean, we've really got a lot of progress so far. I'm pretty happy with it. So I hope that this has been enjoyable. So if you like this content, go ahead and drop me a follow here on Twitch, where I do these coding streams Monday and Wednesday, and I do gameplay streams like every other day. So good times. I am going to be continuing down this game development path for a while. I'm using these streams as a way to kind of keep pushing me down that path so I can work towards some larger goals, more like life goals, rather than just stream related stuff or whatever. It's like bigger than that, but I'm using the stream as a way to help kind of keep me going in the right direction. So also, if you're watching this on YouTube, you can do all the fun YouTube stuff. Click that like button, kick that subscribe button, notification bell, leave me a comment. Again, I would say, like, I always appreciate like constructive criticism and all that. I'm not perfect, nobody's perfect. So when it comes to like these coding streams or whatever, definitely be helpful. Unfortunately, it's not necessarily the most applicable thing on these where I'm doing tutorials, because it's not really my code that you're criticizing. It would be the person who made the tutorial. But I mean, still, if there's anything that you think I could do better with the way I present these or the way I try to explain things, definitely let me know. It's the only way we get better as programmers is by really taking a critical look at our code and practicing what we do. All that stuff comes into play, so I really do appreciate it. So with that said, until next time, when we come back and wrap this bad boy up and have a fully functional roguelike with Rust and libtcod, have a good day, have a good night, whatever it is, wherever you're at, take it easy.
An anemone or clematis plant's juice can cause a rash. When pruning them, it's a good idea to wear gloves.